Hello and welcome to NARC Live on Wednesday the 11th of September 2024. Coming to you live from Norfolk on the east coast of England with Tammy M0TC.
Hello.
And me, David G0UPL. Lovely to see you. On tonight's show, our special guest is Hans Summers G0UPL from QRP Labs, live from his home in Turkey. We have club news and views, including details of our coach trip to the National Hamfest and these pictures from the weekend. And we find out what on earth this is. We have had several entries. Can't say yet if they're right or wrong, but if you see that gadget and you haven't already emailed us, drop us a message either on BATC or on our Facebook Live page, and we'll reveal all and add you to the list of entries in a short while. Hello, good to be back. So the club news for us this week, the major thing that happened at the weekend was that the VHF contest group of NARC set up at Trimmingham on the Norfolk coast to work the 144 megs contest. We've got some pictures for you that I took on the Sunday when I went to see them. It was towards the end of it there. It wasn't bad weather. They did have some heavy rain, I think, overnight Saturday. But anyway, that gives you an idea. That's a fairly serious setup for VHF. Unfortunately, they were prepared and everything, but they did suffer some terrible S10 noise about an hour just before they started, and it lasted about 11 hours until, ironically, it rained and that dampened it out. And they found that to be a local noise from a local transformer in the end. But they did well, and well done to Phil G4LPP, the team leader, and all of his colleagues, of course, running it here. And you can see there we've also got Linda and Dave there from the Benton DX Club, because we kind of did this together from a wonderful pitch in Trimmingham. Now, of course, you know, if you ever watch football on TV now, you see the team managers and the coaches and things all talking with their hands in front of their mouth because of the strategies they're working out, and they don't want the cameras to pick it out. Well, I was trying to take some pictures of this, and of course, taking part in a contest is also about strategy and everything. So I wondered if this is why some of them were hiding like this when I took this picture. I think they were discussing strategy. Or we could have just been packing up. I'll leave you to decide. Mad. Anyway, thank you very much. And well done again to all of you. We don't know what the official results are. I know the first, say, 12 hours or so, 11, 12 hours were really difficult. Gordon was there as well, G3PXT, on the Saturday night, and I worked him briefly, and he said it was very difficult with the noise floor. But anyway, let's hope they did well. And thanks to you as well if you went to see them as well. I know they appreciated the visitors. Now, I've been rattling on about it for a few weeks now, and all the newsletters and our social media and everything. And of course, last time we were here on NARC Live, but we've booked that Hamfest coach to the National Hamfest on the 27th of September. That's the first of the 2 days. That's on the Friday. Got a coach leaving from Norwich, £30. Pickups from East Norwich at Blowfield and West Norwich at Little Melton. Now, we've extended it. To be honest, we're not quite up to the 25, but we've got 22 people so far going on this coach. So we would love to get to 25 to make it break even. If not, we might be asking for little voluntary contributions towards it. But so we're nearly there with 22 people. So if you want to go, or if you know anybody who would, and you want travel and an entry ticket, I have to put this deadline in of the 18th of September, which is a week from tonight. So you can either book it online, I can email you a form if you haven't already got one. You can come to CNS next Wednesday night and pay if you like. We've got some good old-fashioned printed forms there. You can give me cash on the night, £30, that's travel and entry. Much later than that, and I can't give you an entry ticket because I won't have time to get them in time before we go. All right, so if you know anybody who wants to go, as I said, it's open to non-members as well as members. It is the National Hamfest. I think most people would agree it's probably the largest event of its kind. It's a combination of a radio rally and also display stands from all of the major manufacturers like ICOM and Kenwood and Yaesu, and also the major suppliers like Martin Lynch and Moonraker and Waterson Stanton and Radio World, and they've all got stands there basically. So if you're into the market, particularly for buying something, then it's a good place to go for that sort of thing. And there's some great little companies like BHI who support us with Radioactive as well every year. They make some lovely noise reduction systems. They have a stand there. And anyway, there's lots of details on the National Hamfest website or on their Facebook page. And hopefully we'll get a few more to come. So we just sort of break even would be the ideal situation. But it is going ahead, and tickets are on sale now. And this coming Saturday, we have another social event for you. I was asked, why can't we run more than one radio by the seaside? Well, I mean, we're near the coast here in Norfolk, so why not? So we've arranged one for this Saturday. And again, a Saturday's because several of you said, can we have it on a Saturday instead of a Sunday? And why not? For many people, indeed ourselves, Sunday's often a family day. So Saturday it is, this Saturday. Weather looks reasonable at the moment. Seaview Car Park, Water Lane, West Runton, the usual place. Everybody's welcome, not just NARC members. Other clubs hopefully will come along too. The only thing you need to bear in mind is there is a height limit on that car park now, a permanent height limit of 2.2 metres, which means you can get the average van in. As you can see there, Neil at the bottom right hand corner of that picture has got a standard regular transit type style van that will fit in, but anything really big and tall may not. So do look at that first. 2.2 metres is the limit. There's a cafe nearby, there are toilets nearby, and it's a good place, especially for QRP really, because as you can see, most people are setting up there with low power rigs. And if you come along, rock along with 100 watts, with a long wire or something like that, you could just wipe everybody else out. So, but it's a good fun day for all the family. If you want to know what our hobby's all about, then it's a great place to come. That's this Saturday, roughly between 10 a.m. and roughly 4 a.m. But we don't own that car park.
4 p.m.
4 p.m. Did I say 4 a.m.? Wishful thinking. From 10 till 4, and it's just an informal day. So we hope to see lots of you there. Tammy, you're coming this time, aren't you?
I am.
Good.
Yeah.
So get you on the radio?
But might bring my kite, not to put an aerial on.
Oh,
but just I might bring
nearly
a kite.
let it out. All right. Okay. So good. Looks forward to seeing you then. I'm going to just quickly mention this one more time. This will be the last time I mention it. We are running an intermediate course in person this September, starting the 21st, 28th, and then October the 5th, 12th and 19th. 5 days. And we're open now just about for anybody else who wants to join us. We've got 7 candidates, which is fine. It makes it a nice small course and very intimate. It means we can work well together. The cost will be £25, and that includes the kit that we'll show you how to solder and put together a kit. And also the parts needed for making things like a patch lead and things. We're trying to show you the practical skills, and although you don't need to know these things now for an assessment as you used to for the intermediate, we think these are good sort of life skills to have as a radio amateur. So this is your last call for anybody who wants to take their intermediate and an in-person course this month. Nearly there now for news, but just one thing, I haven't had any members news from you in the last week or so, but I did find this on Facebook a little while ago, and I saved it for a time when we hadn't got anything else. So have a look at this. I thought some of you might be able to relate to this. Ham radio for babies. It doesn't exactly look, well, a bit like you would look when you were a baby, I think, and your dad or your older brother tried to introduce you to amateur radio, Tammy. So do keep in touch with us anyway with sending us your stories. Enough from me, over to Tammy now for Little People.
Yep, here's Little People this week. This is Trouble.
It's a cassette again, the thing I had to tell you about.
Yep.
That is cool, isn't it?
It's no rewind.
So it's an operation?
Yep. He's going to cut it.
Yeah. Remember those days? Bit of sellotape. Then if you're lucky, it won't jam up your cassette recorder permanently.
Do you know, I have to confess, my dad, the other day, he came in from his shed and said, I've had a bit of trouble because I put a tape in the tape player and it's pulled it all out.
Oh, is it? Oh, the belts have probably gone.
Yeah.
The one he stores down the shed?
Yeah.
Yeah, that's what it is.
So
belts have dried up. Well, I'll have a look at that for him.
He had to rummage in the cupboard to find another one and a new tape.
Yes. It was pretty destructive. And remember that pencil thing we talked about. Anyway, never mind. This is miniature-calendar.com, a new picture every day, and Tammy picks one out for us every week. So as I said, please keep in touch with what you're doing. We'd love to hear from you. And we try and, we still meet online, as you know, because it's the best way to bring talks. Indeed, our guest tonight is coming all the way from Turkey. So it's a really good way of keeping in touch, as well as the meetings, of course, at CNS, which are also important. And I'll go over that when we're next meeting there shortly. But now let's go to our competition. When 2 weeks ago tonight, I asked you, what on earth is this? Do you know what? I mean, obviously we know because somebody sent it to us. I hadn't got a clue. Has anybody put it on here? Online?
No.
No, nobody's done that. Okay, so let's get what your entries to us over the last 2 weeks. Steve G3VA says, I think this week's What on Earth is a bicycle or motorcycle spoke threader. I used to have one, but I think it was lost in a house move.
Colin M70PB, is it to put a thread on a spoke?
Iris G4RKK, nice to hear from you, Iris. She said, looks like an ornate nutcracker to me. Yeah, it could be, couldn't it?
Yeah, it could, yeah.
Look at it.
Bob G6PWS, that's a very old bicycle spoke threader, useful in its day.
Mark M7LLS says that, I believe, is a spoke threading tool for bicycle spokes. Fingers crossed, he says.
John G8CHP, is it a thread cutter for bicycle spokes?
And Bruce G4KZT says, I think this is a bicycle spoke threading machine. My dad had one many years ago and he told me that's what it was, but I never saw it in use. Why wouldn't you still want to use it? Or is that another subject? Anyway, we better find out what it is first before I say that.
Well, it is.
But it won't surprise you to know it is
a bicycle spoke die.
Exactly. So thanks to Steve G4GHO for sending us that. I'd never seen it before. Maybe lots of you probably hadn't as well, looking at the number of entries to the competition. But why? I'm just wondering why you wouldn't need one now.
Maybe you can't replace spokes.
Yeah, could be. They don't have a thread. Anyway, thank you for that. Thanks for if you entered that as well. Well done. If you got it right, which most of you did. So Tammy's got another competition question for you now. We'll be meeting you here again online in 2 weeks' time, and we'll be asking you, what on earth is this? This is a one sent to me a little while ago, actually. This is a tricky one. This is genuine. This is a real picture as well. We've cropped this from a real picture. Do you know what that is?
I know that it's wrong, off, wrong.
Yeah.
Wrong, off, wrong.
It's weird, isn't it? I mustn't offer any kind of clues to this at all. But if you know what that is, without Googling it and stuff like that, looking at it, if you know what that is, drop us an email to radio@dcpmicro.com by 3 o'clock on Wednesday week. And we'll reveal all then what this is and show you a bigger picture, which will make a little bit more sense anyway.
You hope? I
hope, yeah. Okay, so just before we meet tonight's guest, which I know we're really anxious to do, let's have a look at this coming week in the club. On Saturday, as I said earlier, we've got Radio by the Seaside at West Runton. Also at 10 o'clock on the Saturday, it's our monthly Koblenz Sked on 7.123 megs. Well, I thought, of course, maybe we can work from the seaside. Ideal for skipping across there to Germany. So those of you who are at the seaside, maybe we can get there a little bit earlier, thinking about it actually, than 10 o'clock, because that's when the Sked starts. And we'll see if we can work Koblenz there on that frequency or thereabouts. That's on Saturday. On Sunday, the GB2RS News at 7 o'clock on GB3MB repeater. On Monday, the Monday Night Net as well, also on GB3MB. It starts at 7:30. And then next Wednesday, September the 18th, we've got Bright Sparks for our younger members and an informal social meeting all at CNS School from 7 till 9:30 p.m, including the show and share table to offer free things which you no longer need and others to fill a hole in their house. Because I'm amazed, I've said this before, how popular that is. I mean, it really alarmed me when people bring you loads of stuff, and I thought, well, they better take that home with them, or it's going to end up our boot. But actually, it nearly always goes and finds another use. So, great thing to do, and it also provokes discussion and and repair of stuff and everything else. That's it. So we'll see you again here in 2 weeks' time. Keep your stories coming and pictures of things you've done, because we haven't had much this week from you. And also anything you like, including us, of course. We send this card to anybody that you feel would be cheered up. We still send roughly one a week to anybody that you think would be cheered by a card from our club. Just send it to this address, radio@dcpmicro.com, and we'll be very happy to send it to them. Now, in the 2024, it's never been harder probably to make equipment that's on a par with the commercial equipment that you see, the wonderful latest radios that come from the big manufacturers and everything else. But there is somebody who is addressing that and makes it very affordable, and that is QRP Labs, who keep coming up with innovative, very affordable radios as kits, or you can even buy them from them now ready-made as well. And we've got the head of QRP Labs, Hans G0UPL, with us tonight, live from his home and workshop in Turkey. Hello, Hans.
Hello, David. Thank you very much for inviting me. A great pleasure to be talking to you again from here, the QRP Labs Corporation Global Headquarters Research and Development Laboratory here in the vaulted heights of the penthouse suite of QRP Labs Towers here.
Well, you really have built that up.
Also known as my attic.
Oh, you've just spoilt that. That is amazing, isn't it? And now we think, and I know this, I apologise for this because I should remember everybody. And of course, you and I have met several times with Tammy on various productions for other organisations as well, like the RSGB and things. But so I can't remember if you've been on NARC Live before, but it's really nice to have you here for our club because it makes it a little bit more personal for us. And as you know, there were 9 of us, I think, recently bought a QMX Plus kit from you as well. So I'm sure a lot of those now are going to be watching tonight. And of course, this is an opportunity. Hans is going to be talking to us. We'll be a bit of interaction as well. We've got a camera set up here so we can show you bits of a kit. But it is a great opportunity for you to interact with Hans. So don't be afraid to send messages either on BATC or on the Facebook Messenger, or Facebook rather, at any time, and we'll read them to Hans probably at the end of his presentation because we'll have time for that as well. But we love to hear your story. And for those who haven't met you before, maybe you could just start by just telling us a little bit about your company, QRP Labs, and why and how you started and where you are now.
Sure, yeah, absolutely. I have spoken to NARC before, and I think you mentioned that I'd spoken to you last year, so I kind of assumed that I'd spoken about the QMX last year, although I can't really remember who I've spoken to and when. And I couldn't find in my file of talks having spoken to Norfolk last year, so I don't think I did. So in the first few slides, I actually introduced a little bit about what the QMX is, just as an insurance policy against not having spoken last year, and against new people who may not have heard of QMX before, and a little bit of an introduction to it. But yeah, about me. So I was licensed in 1994. I then did nothing with my license for 8 years, and then started getting into some actual operating. I've always spent an awful lot more time designing and building homebrewing rather than operating, and in 2010 produced the first QRP Labs kit, which was a QRSS transmitter to accompany a talk I did at Dayton on weak signal modes. And then continued producing that kit along with G0XAR, Steve, who I think is a Norfolk Amateur Radio Club member, I'm not sure. And we continued for a few years, and I continued on my own from 2013 onwards, and really started, I think, taking it more seriously from mid-2013, early 2013, and building up the range of kits. At that time, I was living in Japan, and we were doing everything from my bedroom closet, which was literally a walk-in wardrobe, 4 by 5 feet. And I wish I had some pictures to show you in the presentation, but I don't. And, I could go in there and close the door. I had a tiny IKEA desk in there and all my equipment and shelves of parts and things. And I could go in there and design the kits before everybody else woke up, and evenings, weekends, middle of the night sometimes. And the kits got more and more popular until in mid-2016, I had the opportunity to finally leave my IT software development life in investment banking and do QRP Labs full time. And so that was when we moved to Turkey. And, there was no point staying in an expensive place like Tokyo when I had no particular need to be there. And so, since then, everything has just grown and grown and grown. Very steady growth for the last 10 years, very surprising. At the time I left IT to do this, I took advice from a lot of people, and almost all of them said, don't be stupid. You can never make money selling kits. So especially QRP Labs, QRP kits to a relatively small niche of amateur radio. So it was something that at the time people thought was crazy, but it's worked out very well, and we've done very well. Still growing. We now have 13 people full-time here in our offices here in the attic of our house, and we had even more. I think we were up to 16 people at some point during the summer, because we had some student interns, university students, who needed summer work, and we had tons of extra work to be done, so it worked out very well. And really since 2017, when I started designing the transceivers. The transceivers has been the main product line with the QCX and then the QDX. And I can actually neatly, I think, bring that into my first slide. These were the 3 single band QCXs for CW transceivers, which the first one was in August 2017, was designed for the RSGB YOTA Buildathon, which was held in the UK in August 2017. The enclosure was not part of my kit. It was a third-party accessory produced by a company in Germany. And the original QCX was not very well suited to putting in an enclosure. So they did a very good job, BATC in Germany, to design these machined extensions for the knobs and buttons and make it all fit in this bent aluminium enclosure. But it was always a sort of niggling thing that bothered me, that I'd failed so miserably on the mechanical design and had done well on the electrical and the RF and the software, but the mechanical design was pretty poor. And really everything I have done, from RF, electronics, software development, mechanical, everything is self-taught. So I've been learning as I go over the last decade or so in this kit business. And back in 2017, I didn't really know how to design a kit that would fit into a good enclosure. By mid-2020, I decided I will rectify that and produced the QCX Plus that you see there on the right-hand side. And this time I did design it to fit very nicely in an enclosure, extruded aluminium enclosure, and I got those enclosures produced for us with nice CNC machined front and rear panels and laser etched lettering on the front and rear panels. Then people said, well, that's bigger than the old one and not so portable. Can you make the old one come back? But I didn't want to do that. I wanted to move forward. So I designed within the next 6 months the QCX Mini, which is the one that you see there on the left. And it's very small. It's something like 9 centimeters wide. So that gives an idea of the size. Really small and portable and light, compact. And so again, it was a mechanical advance, the mechanical design. So those were the original transceivers back in 2017. And to date, as of today, we've sold 20,885 of these QCXs across the 3 different models. So it's been a really huge success, and one that I never dreamed of in 7 years, selling that many of a kit. The picture there says QCX Mini, so it fits very nicely into your hand, really tiny rig. Then in 2021, I decided to go into digital modes, and the QDX transceiver was the result. It's slightly smaller than the QCX Mini. It has the same cross-section, the same aluminium extrusion, but it's slightly smaller. And it uses, it includes pin diode switched filters, so it covers multiple bands, 5 or 6 bands, and produces a really high performance digital modes transceiver. It includes the USB sound card and virtual COM serial port for cat control. So it's extremely easy and high performance to interface to a computer just with a single USB cable, and really seamlessly works with WSJTX and other digital mode software. This is a look inside, so you can see there are 3 low-pass filters which are shared between the various bands. I used this, especially for this, I designed this push-pull power amplifier that you can see in the top part, mid-top part of the PCB there. Now, the very nice feature of push-pull is that when you have a push-pull amplifier, the even harmonics cancel out largely, and so you end up only with the odd harmonics to worry about. So the first thing you have to worry about is the third harmonic, and therefore you can really use simpler low-pass filters with fewer components, fewer elements, and you can share the low-pass filters between multiple adjacent bands. And so that's how it covers 5 or 6 bands with only the 3 low-pass filters that you see there. It was also, I developed what at the time was an innovative way of developing the FSK signal output. So rather than most transceivers that do digimodes will be in SSB mode and take audio that's generated from the PCB and just modulate that onto a carrier using an SSB exciter. What I did with QDX was use a nonlinear push-pull amplifier, so the transistor is in saturation and very efficient, and therefore require no additional heat sinking other than the PCB itself. And the way this works is the CAT command from WSJTX sets the USB dial frequency, the base frequency, and then the QDX actually measures by timing the periods between zero crossing what the period of the sine wave is, and therefore calculates what the audio frequency is. And it adds that to the USB dial frequency and commands the RF signal generator, the synthesizer, to produce exactly that frequency. And it results in an extremely clean signal with no residual carrier, no unwanted sideband on the other sideband, no possibility of intermodulation, distortion products, or anything like that, just a single clear carrier at the desired frequency. It's also surprisingly accurate because you get basically over the USB cable, you get these samples in 16-bit resolution, which is very precise, very precisely timed, and you can do this linear interpolation between the samples either side of the zero crossing to find out the fraction of a 1/48,000th of a second sample, and add that to get a really precise frequency. So it produces something in one cycle measurement, it produces something like a 0.05 hertz accuracy at 1500 hertz audio. So it's really precise. And you can also average even more cycles together if you need more precision than that. So it was a really nice way of generating the signal, and I continue with that in the QMX product, which comes next. So this is just a block diagram of the QDX design. I include it because the QMX was based on this electrical design of the QDX. So it has an embedded SDR transceiver, the software-defined radio. So it's not using a PC software to do the SDR. It's embedded in the microcontroller in the QDX itself. And it has a quadrature sampling detector down to baseband, and then it has a 24-bit stereo, 48,000 samples per second analog to digital converter for the I and Q channels. The advantages of software-defined radio, I decided that the QCX, which is an all-analog single-band CW transceiver I showed just now, would be the last analog radio that I designed, because really software-defined radio has huge advantages in terms of performance to price ratio. You can get really, really high performance at low cost. The digital signal processing lets you really have very sharp filtering, very good 90-degree phase shifting to produce very nice unwanted sideband suppression. And the very big thing that you can add features as you go by software updates and fix performance problems or improve performance, add new modes, and so on. And with QDX, I chose a really high-performance processor such that I could do everything using floating point arithmetic. So what a lot of transceivers that use embedded SDR, a lot of lower-cost transceivers, they use 16-bit integer arithmetic because they're limited in processing power. I chose to use quite a powerful processor, so everything could be kept in floating point. And it also has an audio sound card built in, so that can send the audio straight back to the PC without any losses or distortion or hum in cables. Although it's a baseband transceiver, it actually has a superhet at 12 kilohertz intermediate frequency, all done digitally in the DSP. The advantage of that is that when you're at 12 kilohertz, you get rid of any hum problems which have been picked up somewhere in your antenna or something from the mains wiring. And so you stay away from all of that. It really makes a much big performance improvement. There are some disadvantages. Obviously, there's a lot of complexity in the software that you have to write, much more complex than the simpler controller software, which was existing on the QCX, just to control the VFO and memories and keyer and decoder and so on. Here we have a much more complex job because there's a lot of digital signal processing going on, and it requires a much more powerful CPU. The issue with a more powerful CPU executing more instructions per second is that it requires higher power consumption, and then you end up shortening battery life. So this is a big problem for battery-powered operations, where you want the lowest possible current consumption. There's also the issue of processing latency. So when you have an analog transceiver, the processing latency is really very, very quick. It's sub-millisecond, whereas with a DSP-based transceiver, it takes time to do all that calculation and mathematics, and therefore you end up with a latency. Now, if you care about CW performance, this becomes a problem. Of course, QDX was digital modes only, so it didn't matter. But for CW, it does matter. And many CW operators love full break-in which you are listening to the band in between your own keying. And for that, you need a very low latency so that the receiver can come back quickly after you finish transmitting. And a lot of software-defined radio software on a PC can't do full break-in CW for this reason, because the latency that is inflicted on you by the USB processing and the operating system of the PC ruins the full break-in CW. So that's another challenge that you have to overcome. I also included in QDX for the first time these terminal testing tools. So you can log into QDX with a terminal emulator such as PuTTY, and it includes its own internal signal generator, which is connected to the RF front end, the BNC connector, and it can inject a signal and sweep that signal across. And so you can plot the performance of the bandpass filters and see if you need to adjust them at all. So in this particular example, you can see in the middle of the screen, there's a solid blue line just above 7 megahertz, which is for the 40-meter band, but you can see the peak occurs somewhere down around 6.2 megahertz. So that would indicate to you, if you wanted to really optimize your performance, that would indicate to you that you should perhaps spread out the turns on the bandpass filter toroid to reduce the inductance and move the resonance up a bit. So these are very, very useful tools for optimizing for diagnostics, debugging, and so on. Then in 2023, I put together QCX Mini's mechanical design and display with the embedded SDR of QDX and married them together and called it QMX. And my joke at the time was that the M was for marriage, with many other things like marvelous and magnificent as well. But the result anyway was called QMX, and originally was in an 80, 60, 40, 30, and 20 meter version, 5 bands covering just CW and digital. Later, we also released a 20 to 10 meter version, and then more recently, I think April this year, a 60 to 15 meter version, which was very often requested by SOTA operators and POTA operators for portable operations, ideal for those bands. And QMX was basically the exact same enclosure as QCX Mini, the same size, dimensions, everything, slightly different laser etch printing on the front panel. But inside was more like the QDX electrically and software. So it's like the embedded SDR of QDX and the diode switch filters of QDX, plus the LCD buttons encoders of QCX Mini, with an audio output, paddle connector, and it also had SWR bridge built in and switching power supplies built in, as well as very good RF envelope shaping, which was not included in QDX, which was only for FSK digital modes rather than on-off keyed modes. So a QDX plus loads of stuff in a QCX Mini enclosure was what made QMX in May 2023, when I announced it at Dayton, 4 days in May, Dayton event in May. On the right-hand side, the panel is slightly different because it has now a USB-C connector instead of the 3.5 millimeter serial jack connector. That's not used as a power supply, it's used for data only, and provides the USB sound card and virtual COM serial ports, as well as in the firmware update mode, the radio appears as a USB flash drive. So that USB is really the main connector between the radio and the PC for every purpose, firmware update, sound, as well as cat control. This is a look on the inside, and you can see it's really, really compact. There's a main motherboard which has got these T30 sized low-pass filter toroids on. You might recognize the same power amplifier at the top of the middle of the board as exists on QDX. And then there's this plug-in controls board with 2 rotary encoders and buttons on it. And there are 2 plug-in switch mode power supply boards on the left side of the main board there. And so it all really fits together like a 3D jigsaw puzzle, and takes some patience to assemble. Like all the QRP Labs kits, all the SMD components are already pre-assembled by the factory. So it's a matter of fitting together the NP0 leaded capacitors, leaded inductors, winding toroids, fitting connectors, and plugging the whole thing together when making the kit. There's a sort of oblique view showing the two-layer construction. The LCD board on the top and the controls board, and then it all slides into the PCB rails in the extruded enclosure very neatly. The PCB design actually is all on one board, which the first job that you have to do when building it is break apart these PCBs into smaller pieces and then start assembling everything together. That's how it looks when all the PCBs are broken apart. There was also a spare piece of PCB area that didn't get used, and so that was turned into a key fob there for real die-hard QRP Labs fans. You can just file off the edges a bit so it doesn't cut your leg up, and use it as a key fob. I have that on my keyring. That's in the center at the bottom there. This is a picture of all the through-hole components for QMX. So as I said, you can see it's got the connectors, the controls, toroids, capacitors, but all the SMD stuff is done. So it looks like a lot, but it's actually quite manageable. Then in May 2024, so this year, I evolved QMX into the QMX Plus, which was basically, it's pictured here, is basically the same schematic, same firmware, same performance, same operation as QMX, but in a much larger enclosure with the same dimensions and same profile as the QCX Plus. And so it's kind of as QCX Plus is to QCX Mini, QMX Plus is to QMX, that kind of relationship in terms of size, exactly. So QMX Plus was introduced in May 2024 at the Dayton FDIM event and Hamfest again in May this year. And it was kind of I wanted to produce a new product for 2024 because it had been a year since I had the QMX launch. I wanted to produce a QMX Plus as a new product, but at the same time, I didn't want to create a gigantic amount of work for myself by a totally different new product, because there still remains so much firmware work to do on QMX. The big one that still remains is the single sideband implementation, which will be just a firmware update. So much work still remained on QMX that I didn't want to make a whole massive time-consuming product. So I kind of cheated and did QMX Plus. Being the same firmware means I'm still only developing one piece of firmware for QMX Plus and QMX, and the massive impact of a radically new product is eliminated because it's kind of a variant of the same product. So that worked out very well. Here's another view of it with the lid on. It produces a very nice professional-looking transceiver. The rear panel has the similar connectors on it to the QMX, the small version, but there's an additional 3.5mm jack called AUX, which you see there just left of center, and an additional GPS antenna connector, which I'll come on to in a moment. So there are some more expansion possibilities with QMX Plus. Inside, you can see straight away that it's a lot more spacious, and it also covers double the number of bands. So there are twice the number of low-pass filters and bandpass filters. So it covers all the way from 160 meters to 6 meters, and much easier to construct because it's more spacious. And most of the soldering is done on the right-hand side of the board as pictured. So it's the rear half of the board as you would use it. And there are no surface mount components on the bottom half of the board, so that you can't accidentally knock anything off. It might be a good moment, David, you've got a camera showing one of these. It might be a good moment to show the QMX that you're working on there.
Yep, okay, well here it is. So we've rigged up a camera here in the studio. I was one of the 8 or 9, we just did a little bit, a group club purchase of these, which did give a bit of a price advantage and certainly saved a lot of carriage cost as well. So there were several of us with it, and we did make you a promise actually, Hans. I don't know if you remember. We said that when you and I and Tammy last met in July for production for the RSGB, we said that we would have built this. Well, we've half kept our promise because we have started. It would be fair to just, I mean, I know you're much better obviously at describing this than us, but I can just point to you what we have fitted. So all of these parts, as you say, these are all the surface mount parts. Which come already fitted to the circuit board. So you don't need to worry about soldering very small components, because everything that we've soldered on has been conventional. There's lots of these, which are the little capacitors, as you mentioned, little multi-layer ceramics. All of these yellow ones there. There's a blue one, but most of them are yellow. There's some diodes up right there. If we can get that there, you can just see there are about quite a lot. Was there 14 or something? Diodes?
8. There are 12 diodes.
12. Yeah, these are diodes upright to save space, because there's a lot more to this than it looks when you get to doing it. But there's nothing really, if you're a constructor who has made things with conventional wires and you're frightened by this because you see the surface mount electronics, I can tell you independently of Hans, there's nothing to worry about, because there isn't a single surface mount thing to do. It's all been done.
But the bottom side of the board as well, David, because I don't think I've got a picture of the bottom in my
because there's a few surface mount things already mounted. Again, these are already done, aren't they, for you?
Yeah.
So there's just nothing to worry about there. There's quite a few.
I actually think this is probably our easiest kit to build, our easiest transceiver kit to build, because the QCX Plus, which is the same size board and same mechanical concept, the QCX Plus is all through-hole components. So although it's an analog transceiver, there are very many more components to solder, and you have to select out the correct resistors based on the color codes and all of that stuff. Whereas there's a lot less components to solder on this one. So I think this is now our easiest transceiver kit.
Yeah, it's got a lot of space to work on. Tammy, actually, you made a few years ago, I bought a QCX kit and I never got around to making it, so you made it, didn't you?
Yeah.
I mean, how did you find that? That was all conventional, but there's a lot to it, wasn't there?
Yeah, there was, yeah.
In a small space. I think that wasn't the mini, Hans, that was the regular
the original
one.
Yeah.
So we ought to just show people what some of the other bits are, and you can talk us through that. So, of course, there's what we've got lots to do, and you can see this at home if I use my pen to point. You can see these are all going to be coils, which we haven't wound yet. I say it's a raw we, because I decided I was going to put the components on and Tammy make the coils. So she's made this transformer, which was the most complicated one to do, wasn't it? Because you had to twist wires together in a drill and put them in. Tammy, you talked through this. I mean, you made them. We did this on Monday, didn't we? We just devoted the whole day to making a good start of it. How did you find that?
Yeah. The instructions are really good, so it shows you exactly what you need to do.
Yeah.
The other thing, David, that we did, and I'm sure you'll find this interesting, Tammy, is that in the latest PCB revision of QMX Plus, we're now supplying only the thinner wire. So the kit that you're producing, you're building, has 2 diameters of wire, and the thicker wire, 0.6 millimeters, is used for making that transformer.
It is quite tight, isn't it, when you're trying to pull it through? Yeah,
it's quite tight, exactly. And we found, or I did some experiments and found that if you do everything with the thinner wire, you don't damage the performance in any way. And in fact, there's a slight increase in performance, in power output efficiency, reduction in harmonic levels. If anything, a very slight improvement in performance by using the thin wire for everything. So the latest version of the kit specifies to use only 0.33 millimeter, and it makes it a lot easier to build as well, because the 0.33 millimeter, the enamel comes off very easily. You can burn off the enamel, for example, whereas the 0.6 millimeter wire, you have to scrape off the enamel quite carefully, and it's much harder to twist. So it's also, the kits which are being produced and sold now are easier for that reason, because they have this thinner wire used for everything. So
while we do this,
it's another
I'm going to be a bit cheeky because this is a personal question. I don't think we did this, but if you look at this inductor here on the board, which is already pre-mounted, has got a little bit cut off it. Do you think we've got anything to worry about there?
Nothing to worry about. This is another important thing to mention. The ferrite inductors used in the switch mode power supplies, 330 microhenry inductors, are very, very delicate, and the slightest knock during shipping, either from the PCB assembly house in China to me or from me to you, seems to chip off bits of that ferrite. And we've seen it in so many occasions of the kits that we build here as well. It's nothing to worry about. It doesn't alter the performance at all. But what we have done in the latest batch of QMX Pluses, I will show you here, we pack every one individually in its own jiffy bag. So we put it in a electrostatic sensitive packaging, and then it goes into the envelope. Right. And so each one is individually packed now. And that's the case for the boards as they come from the PCB assembly house to my production facility in China, and then from my production facility to me, and then from me to you. All along, it goes in that same padded envelope. And so we are hoping that there will be no more of these chipped inductors.
I meant to message you with it, but as we were here, I thought I'd ask you. Maybe some of my... I've messaged the other 7 or 8 people who bought one of these a few months ago, and they may have something similar, so there's nothing to worry about there. We've also got lots of other parts.
We did try to eliminate it from the latest batch.
Yeah, that sounds good. These are lots of other parts left, so although Tammy seems to have drawn the short straw with all the coils she's got to make, that's each one of these is going to be a little coil, but it's not... None of these are terribly difficult now, are they, Tammy? You've made a few of them. I held them in my fingers a minute ago. I'm trying to just be objective here and be slightly impartial, if you like, Hans, for people thinking about it, because I know that it frightens constructors who've been making things for years.
For some reason, toroids frighten people, and most people know how to count, and I think that's really the only... Counting and patience is really the only 2 skills that you need to be able to wind toroids. And the story about this, my daughter, so the kids went back to school here in Turkey this Monday, and all over the country a collective sigh of relief was breathed by parents who've had to put up with their kids all summer holiday and somehow combine work with child minding, with the schools not being available to do that job. I'm sorry, they're educating them.
That's right. You forgot. That's a Freudian slip.
Yeah, Freudian slip. And so... But she turned up on the first day of her summer holiday, and the evening before she said, "Right, Daddy," and she's 10, so she'll be 11 next month, but she's 10 now. And on the first day of the summer holiday, she said, "Right, Daddy, I'm going to work in the office tomorrow." And I didn't really think much of it. I just went to bed as normal. But following morning, all of our teams start at 8:30 in the morning. She was up here. She was dressed. She'd brushed her hair nicely. She'd even put on makeup. She's 10 years old. Wow. And she sat down. She said, "Right, I'm going to start building some radios." And she built several QDXs over the following days. She wound all the toroids. She did everything herself. And she's 10. So I would say that people shouldn't be afraid of this at all. In fact, Tammy, I would make David wind some of those toroids.
I was afraid that might come.
It is really not difficult. It's the motion that you do with it. Is you kind of like, you feel like you're sewing, in a way.
Have you ever seen me sew?
No, I can't sew very well either. But, it's the motion of going through the hole.
Make him do some, Tammy. It'll be good
I
for
thought you were my friend.
You just got to be careful that you don't go over your last coil.
Okay, yeah. No, I mean, I have done it in my years. Obviously, I've made it sometimes. It was really a way of trying to make some real progress on Monday, because we wanted to show this tonight to everybody here. Can you just talk us through... I'll change the subject quickly, they won't notice. Can you just talk us through these extra bits that you get with the kit? So this is the front panel.
What you're showing there is the front panel board, and is mounted at 90 degree angle to the main motherboard with some 90-degree header pins, and so the female header pins are connected on the rear of that front panel board. You have an LCD module, 16 by 2 alphanumeric LCD module, which you will solder onto that board and fit on with a set of screws that comes with it. And that board also holds the 2 rotary encoders, the 2 buttons, and a tiny microphone, electric microphone, which is also included. And so all of that goes on that front panel board. And then there's another tiny PCB that contains the two 3.5 millimeter stereo jacks. One is for the earphone output and one is for the paddle input. Yeah, that one that you're holding there. And so this all fits together in such a way that everything lines up and you can slide the board assembly into the enclosure. There are no, in common with the QCX Mini, the QMX, and the QDX, there are no mounting screws for the boards or there's no wiring. So that everything is board mounted and everything fits together with connectors across all these kits without any additional wires to be added. And it all slides into its enclosure. And then the end panels have 4 holes in their corners, which screw into the extrusion, the profile extrusion, and hold everything together. Yes. So it all fits together really nicely. I think I mastered the whole mechanical design thing, even though I say so myself.
Yeah, well, I mean, I must admit the QCX was difficult to put in a case, and I think we bought quite a few people at Norfolk Amateur Radio Club were early adopters, and I don't think there was even a case you didn't even offer that one available then, and it was difficult to then mount it in a case because of all the things at different levels. That was the main problem, wasn't it? But these are beautiful.
It was very tough.
These are remarkably. I was a bit panicked, to be honest with you, as well when I opened the kit. For the first time, I thought all these bits of metal are all in there without, no protection or anything. But they're incredibly resilient and tough.
They're really tough.
Is this a silk screen process or is it
it's not
laser?
Silk screen. It's laser etched, and laser etching produces a higher quality, higher resolution finish. If you look at that through a jeweler's loupe or something, you'll find that the pixels of those laser etching are really, really high resolution, and it produces a higher resolution performant printing than silkscreen printing. And also silkscreen printing is essentially a kind of paint which is added to the surface and therefore it can be rubbed off. Whereas this is extremely robust. Now the black coloring is not paint, it's anodizing. So again, it's a surface treatment of the aluminium which hardens the aluminium surface as well as colors it, rather than paint, which can be scratched off. So it is really, really durable, and it's a very high quality enclosure.
Yeah, it really is. It does make it. It's an extra, I think, £22 from memory or something like that. And but it's well worth.
It works out at £19.
Was it 19? Yeah.
Rates. Yes. $25. I've got the prices further along in the presentation.
Okay. That probably varies a little bit every day with the currency, but it's well worth. I don't think you could possibly make or buy or source a case like this with all this metal work. This is really good quality extruded aluminium, and you just couldn't do that for the 20 odd pounds or whatever it is. But
nearly everybody buys it with the enclosure because it's very nice. I mean, there are some people who want to do 3D printing or their own metal bashing, but most of us can solder, but not many of us can do good metal bashing.
No. It doesn't need to be in a metal box then, in terms of shielding and stuff?
No. It doesn't need to. Not really. It doesn't need to be in a metal box in terms of shielding. But it just makes a nice professional finish to it, rather than it being for RF performance purposes. I should probably hit the next slide.
Okay, we'll go to that. And if you want to see any of this again, and of course, just remind everybody at home, this is interactive. We're live with Hans if you're watching this on Wednesday night, and you can ask questions and make comments and anything at any time with it. There's a couple of comments, and I have got them. I'm not going to ignore them, but I will ask you at the end to not knock you off your flow, Hans. But do ask them on either Facebook or BATC, and we'll read them to Hans at the end. Plenty of time.
I'm just coming back to the slides because David and I, when we start chatting, it could go on for hours, right?
Yes, it does.
It does, yeah. And we met as well at RSGB convention 2 years ago. If you remember, we met face to face as well. So
that was nice instead of on a screen. Yeah.
Yeah. Anyway, let me see what slide I have next. This one is just about the features of QMX Plus. So there are some things that I added compared to QMX. So it was kind of an upgrade to QMX as well. Of course, the most obvious one is the fact that it now contains double the number of bands, 160 meters all the way up to 6 meters. And the same 24-bit USB sound card virtual COM CAT as on QMX, clean transmitter output, 3 to 5 watts. It's actually a little bit higher than that. 160 meters, it typically exceeds 6 watts, but it trails off a bit as the frequency goes up. And new to QMX Plus, it has an internal GPS option. I'll show you a picture of that in a moment, and also a dev kit option. The dev kit is I'll show you a picture and I'll talk about it then when I get to it. And it has an SWR bridge and SWR protection and the same switching power supplies with low receive current, around about 85 milliamp receive current as at 12 volts as QMX has, and very nice transmit RF envelope shaping, again, same as QMX. So more features, and these again are the same as QMX for people who are not familiar with QMX. It has a TCXO reference synthesizer, so it's extremely accurate and insensitive to temperature variations. It has a VFO A, B, and split operation, frequency and message memories, built-in CW keyer with iambic A, B, and automatic modes, or you can use a straight key as well if you prefer, a CW decoder, whisker beacon, a very accurate S meter. It's accurate in terms of its 6 dB steps per S meter unit, but and it's typically pretty accurate in absolute terms as well, but there can be some calibration that you could do to really optimize it. And also new to QMX Plus compared to QMX, there's a real-time clock, a real real-time clock. So QMX has a real-time clock, but it's implemented in software. And what that means is as soon as you power off, the real-time clock goes back to midnight. But QMX Plus actually has a real hardware real-time clock, which is backed up by a little coin cell battery. It also has battery voltage monitoring. And I showed there on the bottom right of the screen a typical QMX Plus display with decoded CW on the bottom, VFO-A on the top, indicates the mode, the S meter, battery voltage, and the real-time clock. Some of these items are configurable; they can be switched on or off, and you can choose to some extent what you have on the display. Now, another change for the QMX Plus, I mentioned several of them just now, David, while we were talking, but another change for the QMX Plus revision 2 board that we made was that instead of having plug-in switch mode power supply boards, the same as we used on QMX, I've now integrated those switch mode power supply boards onto the main motherboard of QMX Plus itself. And there are several advantages to doing that. It makes a small improvement to our manufacturing costs because now there's less PCBs to make, less PCB area because I don't have to make those additional PCBs for the plug-in modules. And of course, it doesn't need the right-angled pin header connectors that were used. So there are fewer parts and lower costs, but much more important than that is that it increases the reliability, because a lot of problems we found happened during construction were when people made solder bridges on those SMPS boards when fitting the connectors, solder bridges or intermittent connections or poorly aligned connectors, so there was no connection and so on. So it makes it much easier to construct and improves the reliability of the construction. And another important feature is that it allows us to do a complete test of the board, including the switch mode power supplies. So we now have a test procedure where we clip on the supply voltage at the 2.1 millimeter barrel connector, clip it on because, of course, you've got no soldered barrel connector at that point. It's a part of the kit. So we have a clip that we use to clip on power, and then we can connect the USB connection and run diagnostics in a test script to test the whole thing, including the switch mode power supply and many other parts of the circuit. So it's quite a nice thing to be able to test the boards more before shipping them out. Because a big challenge with kits is that we can't, because we don't have a completed kit in front of us, completed assembled radio, we can't test everything here before we ship it. So it's nice to be able to test more and more things before shipping, and improves the success rate. Current consumption is a very important thing, as I mentioned before, and according to my measurements, if you use linear regulators with the 220 milliamps or so that is required by the powerful CPU that's used in QMX and QMX Plus, you have about 220 milliamps of current consumption, and that will produce around 2.6 watts of heat dissipation in a linear regulator, because all that voltage from 12 volts down to the 3.3 volts and 5-volt rails, all of that is dissipated as heat. Whereas when you use switching regulators, they're far more efficient, and you have around about 1 watt of power dissipation as heat. It results in around about 85 milliamps, so slightly more or less, depending whether you have the backlight switched on or off. And I didn't make huge details in this presentation, but one of the features that I incorporated in these power supplies was that they're all made from discrete components, and the microcontroller is the control loop for the pulse width modulation. And since the microcontroller knows the operating frequency, it can also choose a pulse width modulation frequency where the harmonics do not interfere with the reception on the operating frequency. And so in this way, we're able to have the benefits of switch mode power supply in terms of the much higher efficiency without having any of the drawbacks such as interference on the reception. Now, I'm a very big admirer of Elecraft products in many ways. The performance and the build quality and the features are really superb. The KX3 has a similar performance and a similar embedded SDR structure to the QMX Plus, and according to the website, the receive current is as low as 150 milliamps. And so it's nice to be able to say that, you know, we produced a similar performance transceiver with a very much lower receive current because of these switching supplies. So I am a big admirer of Elecraft. I mentioned them several more times in this presentation, in every aspect except for the price, where my eyes water. And I'm far too stingy to own any Elecraft equipment myself. So I'm using a 6-layer board again, just like in the QMX. 2 of the internal layers are purely for ground plane. And when you have such a large microcontroller chip, which is 100-pin LQFP package, you find it's very, very hard to route all of those connections to the rest of the circuit using a 2-layer board, and the internal layers really are necessary. It could have been done with 4 layers, but I was scared of things like interference between the digital and the analog sections of the circuit. And so I chose 6 layers so that I could have 2 layers purely as ground plane with no tracks routed on them at all. And so this slide just shows how that's done. The 6-layer board is much more expensive to produce, but if you don't use blind or hidden vias, it becomes quite manageable. And especially when you're making 1,000 of them at a time, the cost increment is much smaller than it would be for a small volume. So although it's a much higher performance board, it doesn't cause too much trouble in terms of costs. The microcontroller I'm using, I really love these STM32 series microcontrollers, and the Cortex M4 series, the STM32F4 series, have a built-in floating point unit and very high performance. Here I'm using the 100-pin LQFP, which has lots of GPIO pins. The CPU can run it up to 180 megahertz. We actually run it at slightly lower, 168 megahertz, which is necessary to be able to use the USB peripheral, which has to internally generate a 48 megahertz clock. It has 512K flash program memory. Only 16K of that is used by the bootloader, and the rest is used by the application. At the moment, just to give you an indication, only about 1/3 of the flash memory is being used for the in the microcontroller, and so there's a huge amount of possibility for future inclusion of future features in the software. It has 128K of RAM as well, and again, a very small fraction of that, I'm sure, much less than 1/3, is being used at the moment. It has all the usual I2C USB peripherals, I2S, which is the audio serial transfer protocol used for communication with the ADC chip, and the output chip, audio chip. I use special chips for the ADC audio output and audio input, because the 12-bit resolution of the internal peripherals of the microcontroller are not really enough for the dynamic range that you need for good performance. There's a terminal login again, like on QDX, with tons of tools involved for configuration, diagnostics, testing, debugging, calibration. And the screenshot here shows the band configuration screen where you set up which filters are used for which bands and the frequency limits on each band, and how the PTT is used, enabling bands and so on. So lots of band configuration in this particular screenshot shown. There's also, I now have in QMX this CPU utilization monitor, which lists all of the processes going on in the microcontroller and shows the percentage CPU used by each one, as well as how many times it's being called per second. And it then has a CPU chart of the last 30 seconds of activity. And so CPU is kind of going on around about 35–40%. And so there's, again, plenty of room for expansion and more processing to go on. So this is really useful for me because this screen shows me what parts of the system are using a lot of CPU and therefore where I should target my efforts if I need to improve it. There's a diagnostics screen which shows the performance of the switch mode power supplies, and it also lets you test all the inputs, so the controllers, the rotary encoders, buttons, the paddle inputs, and it lets you test the power output and SWR on each band. So it's probably if you have any diagnostics to do or debugging to do, this is the first screen that you would come to. Then there's an SWR bridge built in on QMX and QMX Plus, the same. The pictured version here uses the thicker wires. As I mentioned, we're now using thinner wires on the supplied QMX Pluses. The performance was found to be the same, but it's much easier to build. And there's just a snapshot of the circuit there. And the QMX has now, when you log in on the terminal, it has the ability to run an SWR sweep from the operating frequency on either side of it. And so it's a very nice tool to be able to look at your antenna. In many ways, you wouldn't really need an antenna analyzer once you have this tool, just for simple SWR tuning. There's also in the top right of the screen there's just an overlay where I've shown a photograph of the LCD display, annotated with how it looks when you've enabled the power and the SWR metering to be shown on the display. So the power meter reads from 0 to 6 watts, and the SWR reads from 1.0 to 4.0 in steps of 0.2. So in this example, it's showing an SWR of 1.8 and an output power of, well, now I have to think about this. An output power of 3.8 watts, if I've calculated it correctly. So there's an RF envelope shaping circuit, as I mentioned, and again, it's built from discrete components. So the digital to analog converter output from the microcontroller, it's actually one of the reasons why I chose this particular processor, the F446, was because it has this 12-bit digital to analog converter output. And you can stream audio samples to this, so you can update it very fast, and I'll come on to that later. And this discrete component circuit I developed for the 5-watt power amplifier kit was used again here, and it has a very high bandwidth and very precise control of the power amplifier voltage, a very linear relationship between the digital to analog converter output and the power amplifier voltage. This is in practice showing how the power output varies. The voltage is very, very linear, as you can see. It has about a 37 dB control range. It doesn't quite get to 0 at the bottom left corner there, but it gets very close to it, a few hundred millivolts. The resulting CW keying envelope, so there's a forthcoming QST review of QMX, not QMX Plus, QMX, in the November edition of QST magazine, November 2024. And as a result, I was able to see the ARL lab test results. They use a 40 words per minute stream of CW DIPs to generate these results, and then they look at the spectrum. And I happen to have on hand the ARL QST review of QCX and the micro BRTX by HS Signals, and also the Elecraft KX2 and the famous Elecraft K3S transceiver. And I scaled them all so that they all have roughly the same dimensions and cover plus minus 1 kilohertz, which is the current ARL standard for measuring the spectrum of CW keying. And you can actually see that QMX there in the middle is even very slightly better than the KX2 and K3S, the slightly narrower spectrum usage when keying at 40 words per minute. So it's a very nice result that really validates how well the QMX is performing. And I use this Blackman-Harris envelope shaping, which is, there was an article in QEX about this a couple of years ago, and it produced, I was alerted by one of my customers to this example, and this article, and it produces a really slightly better performance than the traditional raised cosine envelope shaping. So that's a really, really nice result from that ARL lab test. This is a CW filter comparison between the QCX with its analog filtering and the QMX with its much sharper DSP filtering. So originally QMX was supplied with a single 300 hertz bandwidth filter, and that was centered on 750 hertz. 700 hertz, same as the QCX. Now, more recently, one of the customers and friends of mine had a suggestion: why don't you make 2 filter instances and cascade them with slightly different center frequencies? So I tried this out, and the results that you see here are not some kind of bogus simulation. The results seen here are actual measurement. And with 2 of these filter instances cascaded in series, and one of them is centered on 500 hertz and the other one is centered on 650 hertz. They're both 300 hertz bandwidth. So that's the blue line on the left and on the right, and the red line on the left. And when you cascade them one after the other, you end up with this purple line in the middle, the purple response. So you end up with a much narrower 150 hertz wide filter, but because it's not got very steep edges and a very long delay line that you would really normally use for very narrow filters, you still have a very nice sounding filter without huge propagation delay through the filter. So it was a really, really nice idea to try out. Another example here shows a 500 hertz centered filter and a 750 hertz centered filter, and the overlap results in just a 50 hertz bandwidth filter, which is really, really narrow. So that'll give you a really capable filter, able to really retrieve out weak signals from the noise. In total, the number of filters now implemented, because of being able to combine these different filters in series, these 2 filter instances in series, using a 300 hertz wide filter and a 500 hertz wide filter on different center frequencies, it results in this huge array of possible filter bandwidth and center frequencies. So the filtering in QMX is really, really nice now for CW filtering. There's also now, also earlier this year, a very sophisticated AGC system with lots of configuration capability on where you want the threshold to occur, how much slope you want, the recovery time. All of these things are now configurable. It's a little bit over-configurable in some ways. It would be nicer, I think, in the near future if I was to introduce some kind of recommended settings for slow, medium, and fast AGC, where it was easy to configure. Because at the moment is really, really over-configurable, and so many users may not wish to have that high degree and that much thinking to do about how they want their AGC to operate. All of these, the screenshot I'm showing here is from the terminal login to QMX, but you can also do all of the same settings using the LCD and the buttons on the screen itself. All the same configuration menu is accessible there too. Here's a picture of the real-time clock battery, which is just installed on the rear of the front panel there. We are not able to ship batteries with FedEx and DHL Express, and so we don't supply the battery. But this CR2032 battery is the most common and ubiquitous battery you can imagine. and it's way over capacity for the job. I calculated it would power that real-time clock for about 20 years. A much smaller battery would have done the job as well, but I chose this one because it's the most common and easily available, inexpensive battery. This is the development board that I was talking about, and it's just a matrix board with pin headers connections that you could make to the main board for power, I2C, filter connections, audio connections, the connectors at the back. So there's a lot of things that you could imagine doing with this, like a battery and a tuner. I've seen pictures, and I'm planning to have a section on the website where people can, where I can include people's projects that they've done. There was a guy who'd done a built-in speaker, for example, a guy with a built-in auto tuner. There are so many things that you could fit in here because of the space available. So you've got about 2/3 the volume of the case available to do your own stuff. And this board just sits there at about 11 millimeters altitude above the main board and allows you to do all of those things. This is the internal GPS option. It's a very, very small board. It's less than 1 square inch of board and has this SMA connector, and it includes this active patch antenna. Sorry, I always get hoarse when I'm talking this much. And it includes this active patch antenna, which plugs into this coaxial connector, SMA connector on the rear panel. It currently sets the real-time clock and is used to set the locator for the Whisper Beacon feature, if you use the Whisper Beacon feature. It also has this very nice tool on the terminal lock-in where you can see all the parameters retrieved from the GPS, such as the location, time and date, and it gives you all the parameters of the satellites that are being received, as well as a sky plot, which shows the signal-to-noise ratio and the satellite IDs and so on. So it's a very neat tool to play with, just for fun, but quite cool. There's a mode also where you can see the raw serial data scrolling up on the bottom part of the screen, and that's again just a cool thing to see and debug. So I also forgot to mention on the right-hand side here, I show how the same tool can be run on the LCD itself. If you're not logged in from a terminal emulator like PuTTY on a PC, you can just run the same tool standalone on the QMX Plus itself, and it will show you a more limited information on the LCD screen, such as the latitude, longitude, the altitude, and the locator, the grid subsquare locator. So now moving on to a big topic, which is the SSB implementation on QMX and QMX Plus. And I first include just this introductory chapter from introduction chapter to chapter 15 of the book, Crystal Sets the Sideband, which is a PDF book which I hosted on my private website, Hans Summers, or personal website, hanssummers.com, many years ago. And this was written by Frank Harris, K0IYE. I really, really love this book, and I would recommend everyone who's interested in building anything to read it, because he has a style, the way he writes, which just inspires you. And his book covers all the way from the basics to actually building your own CW transceiver and then even your own single sideband transceiver. And I laugh when I see this introduction to the book, because he talks about Nobel Prize for sideband and then his old school principal, Glenn, W0FQK, and how he introduced him to sideband, and he thought the whole thing was very complex and modulation for millionaires. He's got a great way of writing, and but I chuckle, Nobel Prize for sideband, because it really is complicated. But whether you do it with the traditional methods or the SDR methods, it's a complicated, much more complicated thing to do than a CW transceiver. Now, on QMX, it has and QMX Plus, and this board shows the QMX, by the way, but QMX Plus also has it on its front panel board. It has a built-in Electret microphone for when it can do SSB. And this was always going to be a future goal of SSB, of the QMX, to do a firmware update that would allow it to do SSB. It also has a plug-in microphone and PTT capability, which basically plugs into the same port used as the paddle, if you want to use an external microphone. And the idea is to use envelope elimination and restoration, which is the technique used in the micro STX and the true STX, which was developed by Guido PE1 NNZ and Manuel DA2 MAN. So a little bit more about that. These guys, originally Guido PE1 NNZ, developed a special firmware that ran on my original QCX board. So he deleted a whole bunch of the components and wrote his own special software to actually implement an SDR in that Atmega 328 processor, which is an 8-bit processor running at 20 megahertz. So it's absolutely incredible that he was able to integrate this SDR processing into this very minimal hardware and very minimal software. Numerous others then also made variations of the firmware, including Barb WB2CBA, who's Turkish, so he's my adopted countryman, and but he adopted New York as his home, so he lives in the US. And then there were many poor quality Chinese versions of this. So DL2 MAN and PA1 NZ did not do any kind of protection licensing on their firmware. They just announced that it was completely open source. And then Chinese went and produced lots of poor quality versions, as well as some good quality versions. But it was very hard to know which version you were getting. And it's still all over AliExpress and eBay. You can find this thing everywhere, as well as the true SDX, which was then the version that Emmanuel and Guido actually kind of authorized, that was produced by only a couple of higher quality manufacturers. So there's a lot of controversy about this whole thing, and the poor quality version, are they clones or not? I personally say they're not really a clone because they didn't break any license conditions, because there were no license conditions at the time. So a comparison. So QMX, the idea is that the SSB will work on the same concept as on micro STX, which I'll come on to in a moment. But the QMX has a very, very much more capable hardware, as well as a very much more capable processor. They were trying on the USTX to do envelope elimination and restoration with a very meager 8-bit 20 megahertz processor with limited flash space and RAM, and a 10-bit pulse width modulation output to control the amplitude, which only resulted in about 20 dB of control range of the amplitude in a very non-linear fashion. So with QMX, with the hope was and is that with the much higher performance hardware, it will be possible to do it in a good way. Some references to ER. The whole thing started in 1952, so we're talking about 72 years ago now, with this article by this guy called Khan in an IEE publication. It was then also, there was an attempt to commercialize this with the Polar Explorer SSB transmitter, which has not actually been turned into commercial product, but was a 600-watt SSB transmitter described in QX in 2017, which uses the same technique. And Guido PE1 NNZ had previously, prior to USDX, done the PLL modulation on a Raspberry Pi, and that's also a very good description. And then USDX is on GitHub, which was the original code developed for my QCX to turn it into an SSB multiband transceiver. Now, it's also I'll come on to the other thing I was going to make. The Khan paper in 1952 talks about how this is done. And I know the diagram is not very good, but this was 1952, and the paper scan I was able to obtain is not very high resolution, so you can't really see it. But the paper explains it in some detail about how the SSB signal is split into an amplitude component and a phase component, and these are then modulated separately. And the big advantage of this is that you do not need a linear SSB exciter, a linear driver stage, and then a linear modulation and PA stage. You can do it all with a non-linear PA by modulating the amplitude of that PA like an AM transmitter, and then modulating the phase information which is sent to the transmitter. So that's the big advantage, not needing the linear PA. Not using a linear PA reduces power consumption, increases efficiency, and reduces costs because you need much lower performance or much lower heat handling transistors, and typically no need for a heatsink, certainly at QRP levels. So it's a very attractive thing for those reasons. Lower complexity, lower cost, higher efficiency, and no heat sinks. The way to consider this, and I can explain, it can be explained very quickly how to produce this envelope elimination restoration by considering this thing in a polar coordinate sense. So we're all used to thinking about a two-dimensional surface, such as the Earth's surface, as a set of x and y coordinates. But we're also quite used to thinking it as a latitude and longitude, which are more like polar coordinates. So in polar coordinates, you talk about any location as a angle to that location and a distance from that location. So think about how you point the heading of your rotator. If you have a rotatable antenna, you point it at a particular heading to talk to a station who is a particular distance away from you. And you can describe any point on a surface as an angle and a distance to that location, just as well as you can decide to define it as an x and y coordinate in linear coordinate space. And so the idea with envelope elimination restoration is that you consider the signals in this way as a polar coordinate space. So you start with SSB from your microphone, which is just perfect SSB, and then you do a Hilbert transform with a 90-degree phase shift to get I and Q signals. So this is kind of the opposite to how you demodulate SSB in an SDR transceiver. We're doing the opposite thing now, in the opposite direction, starting with SSB from the microphone and doing a 90-degree phase shift to get I and Q signals. Then we calculate the angle between these I and Q signals by doing arctangent of the Q divided by I, and then we calculate the amplitude or the magnitude of these as the square root of Q squared plus I squared. Now we have amplitude and phase, we can apply these as separate modulations in the power amplifier. Now, in QMX, we have this very nice amplitude modulation, which I showed you earlier. And this amplitude can be used for amplitude modulation or CW envelope shaping, as I showed you earlier, or for the amplitude modulation in SSB. So compared to micro SDX, there's a very nice step up in performance, because what they do in the micro SDX, they apply a gate bias DC modulation to the MOSFETs. And the disadvantage of this is that they develop full power at 1.25 volt DC bias, and the output also doesn't go all the way down to zero. It only goes down to about 5 volts peak to peak, even at zero DC bias. So my 4-year-old has turned up. As you know, David, my 4-year-old always turns up in the middle of these presentations.
That's fine. It was last time, wasn't it? And let's just see him as well if we can.
It was the same with the RSGB. It was the same at RSGB 8.
What time is it with you at the moment? Is it 11 o'clock now, Hans?
It currently is 11 o'clock.
Yeah, my goodness. He's up late, but...
What do you want, then? You want what? Sorry, David, can you just wait one moment? I'm going to go and try and find my wife and take him to her.
Sure, okay.
What I'll do is... He's not seeming to be as peaceful as he was during that.
Right, well, I'm not going to...
presentation.
That's no problem.
You want to try to take you downstairs? You want water?
I'll tell you what, if we come back to me... Oh, you are back to me. We'll have a quick look again at some of this transceiver. I think that's the best way to fill this time, Tammy. That's a very real... experience. So if you could come back to the camera again, Tammy, on here, this would be a good opportunity. I won't read your comments and questions, and there's quite a few already, but if you would like to ask questions of Hans, this is a perfect time, because he will stay and answer these for us. Okay, so this is the board again. I'll just show you in more detail. I don't know if I can show you a bit higher up. So this was the, I mean, I'm just speaking as a general engineer now. I'm certainly not a radio engineer, nothing like as clever as Hans, but I've made and designed quite a few products in my life. And I love this idea here. These are, it's a very, very low cost way of making a PA output stage. And if you can see underneath that, there are just 4 transistors, which are in what's called a TO92 case, which is a plastic case. And they're all soldered in. And then I folded them flat and put a nut and bolt just on them. So there's the nut, the bolt is through there, and just put the washer underneath, and that holds them. He's clear in the instructions to point out that actually it's not the washer that's the heat sink, it's actually the big lump of copper underneath, and what this washer is doing is holding them very close to the board. And one of the questions, I don't know if you're thinking of questions at home, but I've got for him is, you know, obviously this is very technical what he's talking about now, and that's not for everybody. I certainly think for the average constructor, there used to be a magazine years ago, I think, called, with that as a slogan on their front cover. But anyway, I think this is okay for the average instructor to make so far, because all the stuff is, if you can solder a normal integrated circuit, you know, with a normal pitch, then things like these connectors, they're not as small as they look. You know, they may look. This header here. Have we got a pound coin yet? Yeah, so just to give you some idea, I mean, they're not that small. These are 0.1 of an inch separating each pin. So there's nothing to be frightened of really here. If you've ever soldered a traditional integrated circuit onto a circuit board, then you could solder this. I mean, I'm not got to this stage yet, but there's the way that goes on. So it's fairly straightforward, really. I'm still looking at an empty chair in Hans's workshop, so he's doing very important childcare there. Absolutely right too. But it does seem a nice kit. At first, in fact, when you open it, I don't know what you thought, Tammy. I just felt it wasn't that. There wasn't much to it really, because there was quite small bags, and then this board is full of these surface mount components already put on. But I think if you add them all up, you'll see that all these little capacitors and things which have been put on. You know, this is.
So, David, I'm back.
Oh, you're back. Okay.
He said he's going to be quiet.
All right. Hello. And can
I haven't found my wife. I think she's gone to have coffee with her friend or something.
That's all right. Well, that's fine.
Well, I told him he can stay with us as long as he's going to be quiet.
All right. Hello.
Now,
I can remember from our last time we met in a couple of months ago. Is your name Atlas? Isn't that right?
Is your name Atlas? It is Atlas.
A little bit shy. Maybe, Tammy, can we show both on?
He's having his water. All right, so you're going to sit here?
Here we are, we can see.
You're going to sit here? Okay, go on then. You go and sit over there and you rest. Okay.
He's going to be tired for school.
Anyway, so.
All right, thank you.
As I was saying, the output of this, when you use DC gate bias modulation, doesn't quite go down to 0. And the reason for this is because you've got a 2.5 volt threshold on the BS170 MOSFETs. And when you're applying a 5 volt square wave and you've taken the DC bias to 0, you still have about 2.5 volts at the gate. And so some of that goes through and gets amplified. So you end up not going to 0 and having quite a non-linear characteristic from the control voltage to the output peak to peak. And so that's quite limiting in the performance. Phase modulation, how the phase modulation is applied, is via a small frequency shift for a defined duration, which is applied via the PLL synthesizer chip, the SI5351A. And you can think of this as, if you have a 1 hertz shift in frequency for 1 second between 2 signals, after 1 second, the sine wave will again line up with each other. But if you made that shift for only a quarter of a second and then put it back to the frequency that it was at originally, you would have shifted by 90 degrees. You would have shifted your phase by 90 degrees. And so in this way, you're able to convert between the desired phase shift by applying frequent frequency shifts to the synthesizer. So if you take a sample if you take an audio sample, in my case, 9,600 times per second, At each audio sample, you calculate the Q over I for the phase angle, and you apply that. You have to apply a larger frequency for the shorter time duration that you've got, 1 over 9,600 samples per second. You have to apply a larger frequency to get that phase shift. And the actual formula is that the frequency shift should be the desired phase shift multiplied by the sampling frequency divided by 2 pi. Here, the phase shift being in radians. And so you use this to get the desired frequency shift. And it actually works out very nice and very, very well. For the Hilbert filter phase shift, I use this Hilbert filter designer called the Iowa Hills Hilbert Frequency Designer. And this is a piece of software that runs only on Windows. I use Linux, but it works very well on Wine under Linux as well. And this filter designer has disappeared completely from the internet. You can't find it live on any website anymore. But fortunately, there's this web archive where you can find old web pages, and they've been archived there. And so you can download this filter there. So I generate the filters, the coefficients, which you can see there on the right-hand side, using this tool. And you can choose what duration of how many taps you want in your filter, center frequency, bandwidth, and sampling frequency. You can choose everything, and it gives you a nice set of coefficients, which you can then copy and paste into the DSP code. I use plus and minus 45 degrees so that everything is symmetric, rather than generating a Q by a 90-degree phase shift and non-phase shifting the I channel. It seems better to use plus minus 45 degrees. This is also another interesting thing. I had to make this kind of what I call a virtual DSP oscilloscope, where I want to actually see what's going on in my code. And the only way I can do that digitally is to record 100 samples of these 6 channels into a big table, which I then dump into the terminal as a comma-separated file and load into a PuTTY log file into a spreadsheet and then plot. And that lets me tap into any stage in the DSP and plot out the results, so I can visualize it in the same way that you would on an actual physical oscilloscope screen. Now, a little bit about what we look for in SSB. The classic way to test SSB transceivers is to generate 2 sine waves at non-harmonically related frequencies. And normally people use 700 hertz and 1.9 kilohertz as the standard test signals. This is what's used by the ARL, for example. So what I do in QMX, I have a numeric direct digital synthesis, which is all done numerically in the code. So I call it soft DDS, that generates these 2 tones digitally and adds them up. And then you feed this combined signal to the SSB exciter, and you look at the result of the RF on the spectrum analyzer with its very narrow resolution bandwidth. And what you hope to see, what you'd really like to see, would be just the 2 peaks that you fed in. But what you actually see is a whole bunch of other peaks trailing off from side to side because of the nonlinearity of the amplifier. And so typically the IMD3 is the most often quoted figure and is the difference between the carrier peak and the unwanted modulation peak, the next unwanted modulation peak, which is the third order modulation product. There's a slight difference. Many people use DBC as the unwanted signal level relative to the carrier, but the ARL method is dB relative to peak envelope power. So there's a 6 dB method, the difference between the ARL method and the DBC method of specifying IMD3. So it's important when you're talking about these figures to know which of the 2 ways of reporting it is being used. In my case, I set up a 700 hertz tone and a 1900 hertz tone, and I run these at about 4 or 5 watts peak envelope power, and I measure the results through an attenuator on the spectrum analyzer. What you see on the left side and the right side, the left side is an oscilloscope screenshot, and the right-hand side is the spectrum analyzer screenshot. These are not my results. These are something I just Googled and found, but they explain it quite well. I'll come to my results next. How we grade IMD3, 40 dBc would be considered a really excellent result. 30 dBc would be considered a good result. Minus 20 dBc is poor, and minus 10 dBc is very poor. Now, VK2IHL has got a whole website about the micro SDX, and he measured minus 5 dBc for the micro SDX. So it's a very, very poor result indeed. And I think that comes from the fact that they're using such a non-linear modulation and limited processing. They were able, VK2IHL showed how by using drain modulation instead of gate bias modulation, he was able to improve the micro SDX IMD3 by about 10 to 15 dB. So he got it more close to minus 20 dBc, which was quite a big improvement. The pulse width modulation on the drain bias results in a much more linear control of the amplitude. But this website is well worth a look. David, I will share with you later this file that I use. I don't know if you can publish it somewhere and share it with the, with the viewers. So these URLs could be looked at. But VK2IHL seems to have done a very good job on the discussion. So now I share with you a funny story. I almost finished, David. I won't keep rattling on for too much longer. Okay. But the funny story I have to share about my recent frustrations with single sideband generation on the QMX and how much work it is. Because going back to May this year, I was in US for Dayton, and then the following month in Germany for Friedrichshafen. So it's a very busy time of year. And it's only in the last month or two that I've had time to really start working on this properly. So everything works fine when you have a single tone input. And I chose 600 hertz, and it comes out on the correct frequency with a single tone, and everything is fine. So a single tone has no phase. Well, the phase modulation is constant, so it results in a constant frequency offset at the correct frequency, and everything is perfectly fine. Then this is how it looks on the oscilloscope, which again is all correct and how you would hope it would be. I can even do amplitude modulation, where I'm sending in a single tone for amplitude modulation, and you see the central carrier there, and then the two sidebands above and below it at approximately the correct levels, and then the distortion products further out are very low down, which indicates really good linearity. So amplitude modulation was also perfectly fine. However, when I come to do two-tone modulation, I spent weeks and weeks in despair, and all kinds of things I tried to improve the situation. I could never get out two tones at the correct frequency offsets for what was being passed in. Now, the span on these spectrum analyzer plots is 3 kilohertz in the case of the one at top left, 4 kilohertz at the bottom right, and the other two are 10 kilohertz spans. So it's a very high resolution measurement on the spectrum analyzer. My spectrum analyzer is about 30 years old, but it's a very high performance. It would have been a very expensive spectrum analyzer when it was sold, when it was first produced. I think they cost about $20,000 at that time. So it's still a very respectable instrument all these 30 years later. Of course, I got it second hand or third hand or nth hand. So I was really, really despairing over this. And I went through cycles of optimism and despair. And I went wondering whether Guido P1 NNZ really did manage this at all, or whether it was all a big scam. And between 1952 and P1 NNZ, hardly any attention has been devoted to this at all in the amateur radio space. On the commercial broadcast band transmitters, they very often use envelope and elimination restoration, but they are AM transmitters, not SSB transmitters. And there's almost nothing that you can find. In fact, there is nothing I could find other than what Guido did about directly synthesizing an SSB signal and generating it by applying frequency shifts to a synthesizer, as we do with the 5151A chip in the USDX or in the QMX. And so he's kind of the only person who's done it. And when you look at all the code variants of USDX that have ever been made, nobody ever seems to change that SSB function, because I think nobody except Guido actually understands what it does. People change the displays, they change button handling, they make different band combinations, but they do all this stuff around the edges, but they never change the DSP. So I started even wondering, did Guido even really manage this? And if you go back to the, one transistor FM bug transistor projects, I don't know if any of you have ever built these when you were kids and things. Sure, you can build this one transmitter FM bug, and if you listen to it on an FM radio in another room not far away, you can just about hear what somebody's yelling into the microphone. But if you ever had an AM receiver, an airband receiver at VHF, you'd find that you can also just about understand it on an AM receiver just as well. And so is it really transmitting FM? Probably not. It's transmitting something, but the human ear is very good at picking out variations in audio intensity and interpreting them as speech. And so I was kind of wondering, was this all even real? And I went through these cycles of optimism where I had a new idea of a new brainwave or something I could try the following day and see if I could make it work. And I many times got up in the middle of the night, and I came up here and I spent 2 or 3 hours coding and trying to make measurements and see if I could make this work. And meanwhile, all the pressure is mounting, because the QMX, the original QMX, the small one, was released in May last year, and people are already expecting SSB would have been done a long time ago. And although I never really made any promises, I said always that I'm going to try and make SSB work. I never promised it because I couldn't promise it until I'd actually made it work in front of me. But of course, many people took that as a promise, a semi-promise. So, I even started at some point, to my despair, preparing my apologies. I'm so sorry, everybody. I thought I could make this work, but I can't make it work. I failed. And probably I started writing my own obituary. Yeah, he was not a bad guy. He did some good things. QCX was okay, but when it came to SSB, man, he really let everybody down. So it was very depressing. Some points was very depressing in the last few weeks. And then finally, I was chatting on WhatsApp, text, not speech, but just text, with a friend of mine, Ross EX0AA, and we both had exactly the same idea at exactly the same moment. And I was lamenting my failure to make SSB happen at all. And I kept showing him all these plots and how terrible it all was. And I never saw the 2 peaks and all of that. I suddenly had this idea, why don't I try compiling in Guido's code directly? And almost at exactly the same time, Ross was typing to me on WhatsApp, would it be possible for you to compile Guido's code? And so here is a screenshot of Guido's code downloaded directly off the GitHub link, which I referenced earlier. And there are very, very many differences. So as I mentioned before, he's using 16-bit integers. I'm using floating point. So straight away I had to have a conversion at the input and the output to go from his integer samples to my floating point ones. He also has approximations for arctangents and numeric approximations for the square root function and even the Hilbert function, because poor guy, he's only got 20 megahertz 8-bit processor, so he's very, very limited in how he uses those CPU cycles for such complex DSP as this. And he runs at 4.8 thousand samples per second, which is only just enough to manage SSB anyway. Think about SSB has about 2.7 kilohertz bandwidth, or 2.5 kilohertz, depending on how wide you set it. But when you have a 4.8 kilosamples per second sample rate, you can only handle a maximum of 2.4 kilohertz audio. So he's right at the limit of what would make intelligible SSB anyway. So I thought, okay, I just tried to compile this in and we'll see what happens. And I was I had very, very few hopes for this idea, because really his code and my code is so different. And, I'm using all floating point, and I didn't use any approximations for anything. I used the C library math.h functions for arctangent and square root, and the ARM functions for the DSP. And so everything was so different. I had no hopes for this, but I thought, okay, I'll compile it in and see what happens, and changed nothing about his code except converting to integer the input and the output. And look at what happened. Can you imagine how happy I was when I saw this? And I was inputting a 600 hertz and an 850 hertz two-tone signal. And I actually got two peaks out at 600 hertz and 850 hertz. I was in shock that this actually worked. And all my faith in Guido was completely restored. And I believed he didn't fake it. He really did do it. He made SSB with this envelope elimination restoration technique. Okay, the spectrum is horrible. It's got spikes all over the place and it's wide as anything. But at least you can see those two peaks right there in the middle, right on frequency where they should be. So then it was a matter of going line by line from my C code to his C code and finding out exactly where the differences were going, what was going on here, and why my carefully written code failed so badly, but his worked so well. Well, not well, but it worked, with the limitations, the constraints that he had placed on it with the minimal processor. And so in the end, I found out the cause of the problem was that the math.h arctan function returns a result from minus 90 degrees to plus 90 degrees. It's actually in radians, but we'll talk in degrees because most of us are more used to that. And so it only returns a result from minus 90 to plus 90 degrees, whereas Guido's approximation takes care of the sign of the input I and Q numbers and works out what quadrant the polar coordinate is in and returns a result in the range minus 180 to plus 180. So I finally understood why it was important to take into account these quadrants, but I didn't really understand exactly the proper reason for that. But the following day, I had a nice visit from a good friend of mine who's a physics professor at Ankara's Bilkent University. He's quite a prominent physics professor in quantum mechanics. And we always have a great chat when he comes. He has a summer house only about half an hour from where I live. And when he comes over and we have a good chat, because physics was my degree, my BSc degree long, long ago, and he's also a radio amateur, so we always have lots to talk about. In this occasion, he stayed for 9 hours, and we had a lot of talk about a lot of experience with the spectrum analyzer, making code changes, and eventually he managed to understand what was going on and why the Guido code works, but my original code didn't, because this plus minus 90 degrees, easy when you say it, it only represents half of the polar coordinate space, and the other half is then reflected back onto it, and so you end up with no SSB modulation. You end up just with some horrible mix-up. And so he also explained to me, which he knew about already, that the C math.h library has another function called atan2, which takes its two parameters and divides them and results in an output in the range minus 180 to plus 180 degrees. So I was then able to use the real math.h function atan2 rather than an approximation. And once I started doing this, everything came out so much nicer and so beautifully, and I managed to get to improve the performance so that now I was running at 9.6 kilosamples per second without any approximations of arctangent or square root or the Hilbert transform, and was able to experiment with different lengths of Hilbert transform, different tone inputs. This particular example has got a 700 hertz and a 1900 hertz two-tone input, and the IMD3 is about minus 30 dBc. So going back to the generally accepted results, minus 30 dBc is normally rated as a good performance of IMD3. So I go back to where we were. And so to get this, I'm using a 9.6 kilosamples per second rate for all the DSP. I also do a 32 times amplitude interpolation between samples so that the amplitude is actually being streamed to the amplitude modulator at 307.2 kilosamples per second. That DAC update really is very, very fast, and you can do this kind of thing with direct memory access peripherals on the microcontroller. So at a closer tone spacing, and this one shows 450 hertz and 650 hertz, it's even better. And produce even better IMD3, and also the 5th, 7th, 9th, and so on also drop off much faster. Other bands vary a bit by a few dB either way. There's not very much difference between one band and the next, but some of them give a slightly better performance and some a few dB worse. All the experiments I did were on 40-meter band, just because I had to choose something to, keep experimenting around without varying that. Now, comparing it to other transceivers is actually very interesting. So I mentioned Elecraft a lot, and I have on hand 2 of their QST reviews, as well as the HF Signals Micro BitX review. And you can see that the minus 36 dB versus peak envelope power that I'm measuring on mine by the AROL lab method standard way of reporting it, their way of reporting it, which is what's reported in the QST reviews. Minus 36 dB PEP is equivalent to the Elecraft KX2's typical result, and about 6 dB better than the K3S, and very much better than the HF Signals Micro BITX. And so it really looks like a very good result, and the technique really, really does seem to work very well. So suddenly all my optimism is restored, and I'm in an excellent mood these days, and no longer thinking about writing my obituary. David, you'd be pleased to hear. So next steps that I need to do to complete the SSB project and then actually release something and achieve world domination are trying a higher sample rate. So I managed to get the 53518 updating up to 16,000 times per second, which is the limit at an I2C bus speed of 1 megahertz. Remember, all of these updates require several register updates on the 53518, and it's all done in serial communication. There are a lot of different things you can try with the Hilbert transform, how the windowing is done, and I could also try smoother amplitude interpolation. Right now I'm just using a very straightforward linear interpolation between samples, so I can try varying that. The internally generated two-tone at 9.6 KSPS is from a 16-bit lookup table. It should be possible to generate a two-tone audio sample on a PC at a much higher quality and stream that at 48,000 samples per second over the USB sound card from the PC, and see whether or not that is the limiting factor on performance. And then eventually I have to actually link up the microphone sampling to the SSB exciter and release a firmware version. But, it's all looking very, very promising, and hopefully it will be in the near future now that I've managed to solve these major hurdles. Very briefly, beyond SSB, when I've finished the major SSB, there'll be a massive weight off my shoulders. And after that, I will be able to consider some of my more stretch goals for the QMX. One of the things I did was keep the left and right ears completely separate. So the output of QMX is actually stereo when you plug in earphones. Currently, the left and the right are set to exactly the same audio, but theoretically they could be set to different audio streams. And then you could balance the audio left and right. You could do graphic equalizer so that you could then compensate for people's hearing preferences, or in some cases, if people have hearing deficiency in one ear, then you could balance the two ears. You could also do more interesting things like binaural reception, where the CW tone appears to move around three-dimensionally. So you put a left to right frequency slope, and so you'd hear lower pitch signals and more in the left ear and higher pitch signals more in the right ear. Or even do things like Elecraft have done on the KX2, KX3, where they have a second receiver. So you hear the main operating frequency in one ear, and then you hear another frequency a few kilohertz away in the other ear. That would also be possible. And so these are all kind of stretch goals that I will look on to further after SSB. Other things I want to look at are controlled envelope single sideband. This is like compression. Now, I'm sure, David, you've got all this kind of thing going on in your sound mixing there, where you compress audio and you sound like the BBC when you speak. You can do the same thing with SSB, where you have this controlled envelope SSB. So you improve the you improve the average to peak power ratio, and it's equivalent effectively to multiplying your effective power of your transmitter while still only using QRP levels. Another thing I'm quite interested to look at is a CW to RTTY conversion. Again, the Elecraft radios have this, and it's a nice idea where you can operate RTTY but be keying in on the CW paddle. Then there's all the functionality of the original QSS Whisper Beacon functionality that I want to include. I'm also planning to include basic scripting. So this will be like you can have little basic scripts that run whenever any user event happens on the radio, such as press a button, changing the frequency, receiving a CW decoded. And then you could then use that to customize both the user interface of QMX Plus, but also to control other peripherals which you might have connected on the development board that you'd built, because you've got all these GPIO pins that you can control as well. I'm also considering whether I could produce an internal battery, an internal auto ATU module, and perhaps have a rudimentary pan adapter displayed on the LCD module, so you show what signals are being received plus or minus a few kilohertz from the operating frequency. So all of these things, once I've released SSB and got that huge weight off my shoulders, all of these fun sort of stretch goals will be things I'm also interested to look at for the QMX firmware. So that's about it. Now I come just the last couple of slides where I'm making that I used exchange rates converted today from my dollar pricing, which is how everything is priced in base pricing. So the QMX kit price is in pounds at today's exchange rate, £96 and £19.20 for the enclosure. And then there's a GPS option, £16, and a dev kit option, £6. We have an assembly service too, which is assembly and testing. So you end up with a complete calibrated, tested radio, all assembled for you, if you don't want to do any kit construction yourself. And that's £46 in the case of QMX Plus. We also do the assembly on the other radio transceivers too. Here's the complete range of the 5 transceivers and their prices. In each of these cases, I included the transceiver and the case together. So the QMX Plus is really at £115, a really, really inexpensive HF 6-meter transceiver, multimode transceiver, with the performance of a commercial brand transceiver, but at a fraction of the price. Finally, more information if you need it. We have the QRP Labs website, the shop page, the forum, which is a very, very active forum, the QRP Labs forum, with almost 8,500 members, and a lot of fault finding and debugging goes on this forum, which takes weight off me too. The YouTube channel, where I occasionally post something, not very often, unfortunately, but I do sometimes. And the screenshot there is a nice mountain activation I did with Hannah's DL9 SCO when he visited in May last year, and we took the QMX up the mountain. So that was great fun. So that's it, David. I know it's taken a long time. I always talk too much. I'm sorry about that. My son has fallen asleep on the chair behind me. So he did promise to be peaceful, and he's kept his promise.
That's right.
But I think we can have some questions if there's still anybody awake.
There are, yeah. We've lost a few people, but of course we do record this as well. But a lot of people are still there. And yes, I've got some questions, which I must now go to, because I did ask people. But if you have a question or comment or anything, this is the time to put them on there now, because I can read them to Hans. And we'll start with a question that first came in, I think it was Bruce, wasn't it? So Bruce G4KZT says, I've built several QRP Labs kits and I've just finished the QMX Plus. The output power is a bit low, only 2 to 3 watts from 20 meters to 5 meters. 6 meters, sorry. Can you give any tips to improve this? You make a video tuning up your QMX. You make a video QMX Plus. Yeah, I think he says that you're making. Sorry, beg your pardon. He just says I think that you've already made a video on the QMX, but not the QMX Plus. Is that right?
I can't remember exactly what videos I've put up there now on the YouTube channel. QMX Plus and QMX is basically the same. If the output power is a little bit low, firstly, I always tell people, how are you measuring output power? We use here, for our standard, for our certificates that we produce for each of the assembled radios, we use the NMOS QRP-ometer. So this is designed by David Cripe, NM0S, and unfortunately, it produces an accurate result only up to about 15 meters, and beyond that, the power starts to go down a bit. So you really have to make sure that you're using an accurate power measurement method with a dummy load, a good dummy load that has a good resistive 50 ohm load all the way up beyond the operating frequency you want to measure. And I mean, my favorite method is using a 100 megahertz oscilloscope and 100 megahertz probes and looking at the peak to peak voltage, and then you square that and divide by 400 to get the power output. But you would, despite everything that you do, you will always have to accept that the QMX Plus, because it has basically, you can see here that the 6 low-pass filters, but it's covering 12 bands, there is sharing of the filters involved. And when you look at the impedance match of the filters, you get this kind of curve. And you don't, unless you're going to get the 50 ohm exactly on the operating frequency, you can have a mismatch. Now, this is a compromise inherent in the design, and this is why I say that the power output is expected to be around 3 to 5 watts. If you don't get 3 watts, then you can play with squeezing and expanding the turns on the toroids, and I probably do need to write some documentation about which toroids belong to which band and to demonstrate a bit how to increase that. But this is what we do here in the lab when we build the assembled transceivers and my team tune them up. They just play with the toroid windings, expanding them and compressing them a bit until they get the peak power output. So that's what's really normally involved in tuning up to get the peak. But the other thing to remember is the actual difference between 3 watts and 4 watts, for example, is a tiny fraction of an S point. It makes very, very little difference to the received signal strength at the other end. So it's not worth obsessing over it too much. You generally need to go for a much higher power step, perhaps with an external PA, to make it worth worrying about. But that's what we do. We expand and compress the turns to peak the power output. But you will find that because each band is shared between each filter is shared between multiple bands, and particularly the 20-meter filter is used for 20, 17, and 15 meters, you will find that if you increase power on one, the other band might go down. And so it's kind of a delicate balancing act. But this is a compromise inherent in the design.
Sure.
Another thing to mention is that the firmware at the moment is quite pessimistic about the maximum voltage it applies to the power amplifier. So it is configured to provide only 92% of the supply voltage to the power amplifier on every single band. And it does that because at the time I was worried about component tolerances between builds. And so I decided I would put 92% so that it would always be below the maximum. Because if you hit the maximum, then the envelope shaping would be clipped as it approached the maximum point. So I wanted to avoid that. What I am planning to do in a future firmware update, again, once I get SSB out of the way and I've got freedom to play with the nicer things, is make a calibration mode where it can actually measure the component variations that exist in each from device to device. So then it will be able to get a lot closer to 100%, and that will also improve the power output. So these are all things that I'm planning. But for now, I would suggest, just like you do on the QMX or even on an old QCX or QDX, any of them, when you want to improve the power output on a particular band, you just play with squeezing and expanding the number of turns on the relevant low-pass filter toroids.
Okay, thank you. And just a question on that I think you might have said, I'm not sure if you said it was documented or not. Which ones do you know which coils are in use on every particular band? Because I presume there's more than one very often. So you know which ones to adjust?
Yes, you do. And is that how accurately I documented that? I'm not completely sure. whether I've got diagrams or not in my manual.
Okay, I haven't got
If
the
not,
manual to hand.
I certainly should have. So each low-pass filter consists of two toroids. The 160-meter toroid is only used for 160 meter, and that's the two toroids on the left. The next one is used for 80 and 60 meters, and then the third from the left is used for 40 meters and 30 meters. The next one is used for 20, 17, 15, and then there's 12, 11, 10 on one filter, and then finally the rightmost filter is used only by 6 meters. And so it should be documented somewhere, and if it isn't, I should certainly add it, which of those pairs of filters is used in the sequence I've just described for the various low-pass filter bands, so that you know which ones to expand and compress. The same applies, by the way, for the bandpass filter. So the tools all exist, as I mentioned, in the terminal, when you log in on the terminal, that allow you to generate the frequency internally and inject that into the front end and adjust where the peak is, so you can get it exactly peaked.
Because there might be part of a band where you prefer to work. I mean, and that will certainly apply once you start getting into whether you're going to be using CW mainly or SSB. And I guess that what Bruce is saying, he wants to just optimize it for whatever part of the band that he wants to do.
Well, the bandpass filters are not that narrow that it makes very much difference. And so it's more about, I think, just centering the filter on the band generally. Most of the filters are not that narrow that it would make any difference where you are on the band. But certainly to optimize it, squeezing and compressing toroid terms is what you do. It's worth mentioning that if you don't do that and all you've ever done is just counted how many turns you wound, you still end up with a very good result. It's almost optimum. So we're only talking about, the perfectionist here.
Yeah, no, it's fine. Thank you very much, Hans. I'm sure that's helped Bruce. I hope it has. Got lots more questions to get through, so I need to get through those. Martin G0UPL, a very good point here. He's one of the people who bought them in our little group of friends who bought one of these together. He says, as I haven't wound my transformer yet, can I use the thinner wire supplied as you stated you do for the new version 2 kits?
You can, and whether you have enough or not, certainly if you have enough left over, you can. Yeah, there's absolutely no reason why not.
So it might be wise then, in that what you just said, possibly to wind your other coils first,
right?
Wouldn't it, and then see if you've got enough left over. Yeah.
I mean, it doesn't. It only requires something like 30 centimeters of wire for the transformer. So, and you've got something like 3 meters of wire supplied.
Right. Yeah. So
and we generally are a little bit on the positive side when supplying slightly longer, because people might make a mistake or cut slightly more than they need. But it's also worth mentioning that it's very insensitive to wire diameter anyway. So any old wire you have around, if it was 0.4 millimeters or 0.35 or 0.5, it wouldn't really matter. It doesn't make any difference.
Okay.
So
just for your reference,
0.33 because it makes it easier. It makes it easier to solder and easier to wind, and it appears to make it slightly better performance too.
Well, I just offer this as well to Martin and everybody else who's going to build one of these. I've got quite a few good for stocks of different wires. I didn't know that it wasn't critical what dimension, so if any of you do run out of wire, let me know. I've got some enamel copper wire in most of the sizes, all SWG stuff, so that'll help you. Thank you for that.
These are very good questions, by the way. They're very common questions that come up. Yeah.
Well, especially when we're just at several of us, I think, at the same stage of building it or maybe finishing them, hopefully in the next few weeks. Paul M1AFQ, he says that he has bought and paid for a QMX quite some time ago, ready built, he says. I know it takes a while to get it, but was wondering roughly how long from buying to delivery usually takes place. Now, you said something about, I think, when you buy one ready-made, it adds a bit of time, doesn't it?
Yeah, we currently are shipping kits which were ordered in mid-May, and so we're about 4 months behind at the moment. We have caught up substantially from where we were, and at one point we had over 900 people on our waiting list. Now we're down to under 550. The business is slightly seasonal, so we always find that in summer months things are a bit quieter, I suppose because it's more an indoor hobby typically for many people. And also in summer, we often have this additional students on our workforce. So we managed to catch up a bit.
So can I, again, just to clarify absolutely for everybody, this is built units, isn't it? This is delays in built units.
Yeah.
But whereas your website,
units,
I think, tells you if the kits are in stock, they're in stock and they'll ship within a few days, presumably.
Yeah, currently we have every kit we have is currently in stock, and we always ship that within one business day.
Right.
It's the assembled radios which have been very popular and built up quite a waiting list. As I said, it exceeded 900 at one point. I think we're now down to about 530 or something. There is a page on the website where I update every single day, and you can follow where your order is in that line. So you've got an order ID, and you can see where you are in the queue. And, we're producing something like 50 kits, 60 kits a week, around 200, 250 kits a month. So that gives you an idea. If you ordered now, today, it would probably be taking about 9 or 10 weeks to get it.
Made up, again, assembled,
yeah.
you're talking about, yeah. I can tell you that from experience, we bought about, I said, 8 or 9, I can't remember exactly the number of kits, and they did ship within a couple of days. We chose the DHL option because you said that generally works best for the UK. And we did get it then within a week from that.
Typically to the UK, it's taking around 5 or 6 days average.
Yeah. It was about just over a week from when I placed the order, I think, to us getting it. Just mention at this point as well, I see a couple of people have said, they missed the club by and things of it. If this has inspired you to give it a go and you're a member of Norfolk Amateur Radio Club, I don't mind trying to facilitate and put a few of you together to make an order. One of you can order, and then you can just share the cost. That's what I did. I exactly shared the cost. And where you'll find the biggest saving, I think there is a bit of a saving in discount if you're buying quite a few. But the biggest saving we made as a group was shipping, because it didn't cost that much more really to ship 8 or 9 kits than one. And I think so. That's what I'd recommend to you.
The shipping with DHL Express is the same from 0 to 2 kilograms. It's the same price. The TNT option is slightly increases every 500 grams, but it goes up quite shallow. So you make a huge saving on shipping for sure.
So if just again a quick shout out to anybody in NARC, let's say within the next week, if you want to order one and you want to be put in touch with other people, if you drop me an email, the usual address, radio@dcpmicro.com, I'll put you in touch with each other, and then one of you can order and the rest of you can share it. I'm happy to facilitate that and do whatever I can to help as well, because we did make a substantial saving, I think, overall. Must get back to some questions because it is getting quite late, and it's getting very late for you as well, by the way. It's getting near midnight, isn't it, for you? There we see. We've got lots of questions just come in recently. Where are they next? Paul, that was next, I think. A couple of non-radio questions, again from Bruce. This is for Hans. Are you now fluent in Turkish? And how on earth did you get 16 people in your attic? That's a good question.
Firstly, we have quite a big attic, and we have 4 rooms up here which are all used, and it's quite big up here, and so that's how we managed to fit the people up here. We also have a separate entrance, so my wife, who designed the house and managed the construction of the house, had this brilliant idea of making a spiral fire escape style staircase on the side of the house. So they have their own separate entrance too, so they don't have to come through our house to get to the attic. And so it's very convenient. Am I fluent in Turkish? I really don't think I am. Sometimes I manage to get by and have a reasonable conversation with people. All our employees don't speak any English, they only speak Turkish. But that didn't really help me much because we're always discussing the same thing. So my vocabulary was very limited to, what mistakes they've made packing kits, or when cargo is arriving, or what components they need, or they need new solder or whatever. And so I have mastered those things. But I think in general, if I was stuck in a discussion of politics or history, I'd be completely lost. I really haven't put very much. I mean, I lived here for 8 years, so I had to pick up something seeped in that time. But I really haven't put very much effort intentionally to being able to learn Turkish.
Is that because a lot of Turkish people do speak English, as we expect, as certainly when you go to tourist areas, that's what you expect?
Right. They do a lot. Yeah, that's true. But it's also because I have put all of my efforts into these kits for the last 8 years. It's been a night and day, 7 days a week thing.
Yeah.
And I've never wanted to stop doing that in order to put time and effort onto any other thing.
Understand. Thank you.
I mean, between the kits and the family, I prefer not to spend any time doing anything else like going to Turkish lessons.
No, just as I won't keep it on this because we say we've got a lot to get through. Do the children learn both English and Turkish?
Yes, they do, yes. So
that's
they're
a
very,
standard
very
thing.
fluent in Turkish. Their English is almost as good as their Turkish. The school they go to, they have about 15 hours of English lessons per week as well, plus what they pick up from me. So yes, they do. Yeah.
Good, thank you. Now, next, Bruce asks you, or just says, thank you very much for a most informative talk. I admire your electronic and mechanical design skills. Good luck with the SSB firmware, he says. I know there's lots of others for that. And world domination, as a PS. But I'm going over to Facebook now. We've got a question on there from Martin Costa. I've forgotten your... Oh, no, M0XKM. Sorry, I forgot your call sign for a moment, Martin. Fantastic talk and product. I missed the club buy, but will be getting the kit for a winter project. May the need for an obituary be a long way off, Hans, he says.
Thank you.
Martin G0UPL says, so pleased that you've cracked the SSB. Is that as that's the mode that I hope to use? But your wonderful explanation has gone straight over my head, but so glad it works. I think that would apply to more than you, Martin, I think.
Look, I will figure out how to make a good explanation. When I've figured out the SSB and released it, I will try to figure out how to make a good explanation which is properly explained, and I will make a YouTube video of it. I think that's fair. One other quick comment, by the way. A lot of people would say that 5 watts of SSB is not particularly useful, but it also opens up non-FSK digital modes. So there are modes like PSK31. Okay, it's a bit outdated now. Not many people use it, but a lot of people are using Vara and WinLink. And 5 watts of these modes is quite useful, but they won't operate on a QDX, for example, which is pure FSK, because these modes are also multiple tone or phase shifted. And so these require an SSB transceiver. So the SSB capability doesn't just open up voice communications, it also opens up other digital modes which we can't yet cope with, which are non-FSK modes, like Vara, WinLink.
Yeah, well, I was going to say, we had a lovely talk by, I think, Mike Richards on Vara last year, and that was really good, and it's such an efficient bit of code and a lovely code that goes with it as well that's available out there, so that'll be really good to see. Must crack through some of these things here. John M0MTW says, thanks Hans, a very interesting and informative talk. Greatly appreciate your time tonight. I much enjoyed building and using the QMX Plus. So John's finished. I think he was one of our group as well, I believe. Victor G3JMB, thank you very much for an amazing presentation. A genius, he says, and I think there's a lot of people who would agree with that. I'm sure you'll be too modest. And Paul M1AFQ, I must be getting close now, thanks. He was the person who queried about how long it takes to get a built product, a kit.
I don't think genius is fair, by the way. It's not about modesty. I don't think genius is fair. I think it's about being too dumb to know when to quit. Not giving up is much more important than being clever.
It's nice as well, I think, and I'm not, I really aren't at anything your level, and especially on software, it loses me. I'm a hardware age person, but what I think it tells me that you're a true engineer, though, is that it's not good enough just to make it work, tinker with it until it works. You need to understand it, and you really want to understand it, don't you? And that is the secret of mass producing anything, I think, in my little experience of life. When I may design something, I could design one and it works. I design another, make another one, and it doesn't work. That's not good enough, because when you get to make 100 or even 1,000 of a product, it's really got to be universally working, especially when someone else is going to build it. So you must be very confident.
It's got to be reproducible. It's got to be able to be built by a whole range of people with different experiences. I don't want thousands of people coming to me asking for support. I can't cope with that. So it has to be reliable. It has to be well documented. I try to make sure that I get the best performance I can out of it for the cost of the components. So that's very important to me. But still, I think overall, the most important thing is just to have a passion for it and to keep going and not giving up.
Yeah.
And there are very many people I've met, and it was the same in my corporate career in IT, in banking. I met loads of people who were way more smart than I was, but who didn't have the perseverance or the application and who would give up too easily. So I always say being too dumb to know when to quit is the most valuable asset.
I think,
and
yeah, my wife would call that stubborn. That's what she'd say, but it is. It's
my wife says the same thing. She says you're an obstinate.
Well, it is nice to do it, but it's been wonderful, Hans. It's lovely to see you again. It's only a couple of months since we last met for something similar, but you've explained a lot more tonight, especially about the SSB, because at that time you were just hoping it was around the corner. So clearly you've had a lot of battles to go through. But as I said in exactly the same way a couple of months ago, I think when people see your talk, see how passionate you are, they're investing as much in you as a person and what you want to do, and you're still telling us about things you haven't designed yet, which you're willing to give us, which you're a good salesman. Actually, they say once you've got that cooked, you shouldn't try and sell any more. But you're telling us and sharing us the enthusiasm and the ideas that you've got to take this further, and also I'm sure that not all of us can't wait to see what you do next. So Hans, hopefully this is definitely not the last time we see you online and on a program for there, and thank you very much. I've just got one other comment, by the way. Tammy's just saying, Rick M7 GMT, the amateur practices until he gets it right, the professional practices until he can't get it wrong. That's a good bit of advice, isn't it?
Yeah, I have to think about that.
I'll read it again. Rick, thank you. The amateur practices until he gets it right, the professional practices until he can't get it wrong. I think that means you can make, like you said, reproducing a product.
Yeah.
That's
true. Yeah.
But Hans, once again, thank you very much. Very inspiring. I hope this has encouraged lots of people. By the way, for people who are watching this and thinking, well, some of the technical stuff lost them, you don't need to know all of that, do you, to get it working? And because
no.
There's at least now I know 10 people in our club who've got one of these, and I'm sure we can help each other as well. When we get to the stage of testing them, if we have any issues.
I mean, you can literally paint by numbers, as we call it. Like the kids' book, when you have a series of dots which are numbered 1 to 50, and you just follow the dots and you connect up, and magically a picture comes out. Or painting different numbered areas with a different color until you see the picture. You can literally just follow the manual and paint by numbers. Or you can buy an assembled radio and it's all guaranteed to be working and tested for you. Or you can get into as much detail as you want about how it works and understanding how it works and experimenting with it. And so you've got, I think, a full, what I call a human dynamic range in how you want to approach it, from a very simple level to a very in-depth level. So many people learn a lot from these kits too, and I try to put as much explanation in the manuals on how they work as well as possible.
There's a lot of detail. Again, for any of you watching, if you just want to sit and get an idea, you can go to your website, QRP Labs, and just find the documentation on this, and it's very obvious what goes in. Someone actually, I think it was on our last broadcast that we did together, they likened it to the old Heath kit, which was a really good traditional old brand of kits. They probably, virtually invented the electronic kit industry many, many moons ago.
A lot of people have said that, and it's very flattering.
Because that was really detailed stuff, wasn't it? Every detail was covered.
A beautiful 8-digit Nixie tube frequency counter here, which is the Heath kit, not built by me, but it's very flattering when people say that. It's for me important for my survival as well to write good documentation, because I don't want thousands of people to have problems and come back and ask me questions, because that limits. I already have struggle enough to find development time, and so it's in my best interest, as well as your best interest, that the manual documentation is good.
I find it very good, and I'm sure everybody else. Hans, we're going to let you go.
It's been a good chat, David. Thanks very much.
Very, very good evening. It is 10 o'clock for us. It's midnight for you. And thank you once again. And I say I can't wait to hear from you. Do drop me a note when you're ready to talk about your next creation, because we can't wait. Thank you very much indeed to Hans G0UPL.
Thank you, David. Thank you.
Thanks. What a great evening. What an inspiring talk as well. Especially if you like building stuff. And we are going to finish this, aren't we, Tammy?
We are.
This side of Christmas. Well, this side of Christmas as well. Just a quick moment just to tell you about what's happening at the club again this week. So Saturday, remember Radio by the Seaside, the usual place at West Runton, Beach Road, from about 10, although before that, probably I'm going to try and arrive there maybe about 10:30, 9:30 now, something like that. But it's very, very open, flexible, informal day. Maybe we'll then be able to do the Kablensked for people there on Saturday the 14th, again at 7.123 megahertz. If you're not doing that, work it from home. On Sunday, it's the GB2RS News at 7 o'clock on GB3MB, and then on Monday, it's the Monday Night Net, also on GB3MB. It's starting at 7:30, and then next Wednesday, a week from tonight, on September the 18th, it's Bright Sparks for our younger members after a summer break, and informal social evening at CNS from 7 till 9:30. That's it. Thank you very much indeed for joining us tonight. Thanks again, of course, to Hans, our guest, and thanks to Tammy, and we'll see you again in 2 weeks' time. Until then, from Tammy.
Bye-bye.
And from me, David G0UPL. Take care. Look after yourselves. Bye-bye.